I settle into a quiet space tonight where thought moves like water, where questions that have wandered through human minds for thousands of years begin to surface, one by one, like stars appearing as dusk deepens into night. There is something about consciousness that pulls at the edges of understanding, something vast and intimate all at once, the way we know we are here, the way we know that we know, this strange inner light that flickers behind every thought, every sensation, every moment of being aware that we are aware. Tonight, I find myself drawn toward these questions, not to answer them with finality, but to walk among them, to let them unfold slowly, like watching fog lift from a valley floor. The word itself feels ancient. Consciousness, from the Latin consciere, to know together, to share knowledge, as if awareness were always meant to be something witnessed, something held in common, even when it feels most private, most singular, most impossibly our own. Philosophers have sat with this mystery for millennia, turning it over in their minds like a stone worn smooth by centuries of touch. Scientists have approached it from every angle, building instruments, designing experiments, searching for the moment when matter becomes mind, when electricity becomes experience, when the universe looks back at itself through human eyes. And yet, after all these years, after all these brilliant minds, the question remains, soft and persistent, like the sound of distant water. What is it? This thing we call consciousness, this inner theater where the world appears, where colors bloom and sounds echo, and memories drift like leaves on a slow current. Is it something the brain produces, the way a heart produces a pulse? Or is it something older, deeper, woven into the fabric of reality itself? I imagine standing at the edge of a forest at twilight, that hour when the world seems to pause between states, neither day nor night, but something in between. The trees are still visible, their branches dark against a sky that holds the last traces of blue, fading now into violet, into indigo. This is where the inquiry begins, in this liminal space, where certainty gives way to wonder, where the familiar becomes strange again, the way consciousness itself is both the most obvious thing we know and the most mysterious. Every moment of our lives, we are immersed in it. This constant stream of experience, thoughts arising and dissolving, sensations appearing, emotions moving through like weather systems, and yet we cannot step outside it, cannot examine it from the outside, because the very tool we would use to examine it is consciousness itself. It's like trying to see your own eyes without a mirror, or like a river trying to hold itself in its own current. The great thinkers who have wrestled with this puzzle, they come from every tradition, every culture, every century. Some approached it through meditation, sitting in silence until the nature of mind revealed itself. Others approached it through reason, building elaborate arguments like cathedral architecture. Still others through science, peering into the brain's intricate folds, watching neurons fire in patterns of light on screens, and what they found, or what they proposed, or what they glimpsed, these theories and ideas, they form a kind of constellation, each one a point of light in the darkness, together mapping out the shape of something we still cannot fully see. Tonight, I want to walk among these ideas, to let them settle around me like snow, to feel the weight of each question, the beauty of each attempt to understand, not to arrive at a final answer, but to trace the path of human wondering, to follow the thread of inquiry as it winds through history, through laboratories and libraries, through monasteries and hospitals, through the minds of those who could not rest until they had looked as deeply as possible into the nature of their own awareness. The night is quiet here, and in this quietness, the questions begin to gather, soft and patient, waiting. The story begins, as so many stories do, in ancient Greece, where philosophers first turned their attention inward and asked what it meant to be a thinking thing, a feeling thing, a being who could contemplate its own existence. Thales of Miletus, one of the earliest voices we can still hear across the centuries, believed that all things possessed a kind of soul, a vital principle. He looked at lodestones, magnetic rocks that moved iron filings without touching them, and saw evidence of an animating force spread throughout nature. Consciousness, not as something rare, but as something woven into the very substance of the world. This was 600 years before the Common Era, and already the question was forming, taking shape in human language for perhaps the first time. But it was Plato, standing in the Athenian sunlight, who gave us one of the most enduring images of consciousness, his allegory of the cave, where prisoners sit chained, watching shadows flicker on a stone wall, believing these shadows to be reality itself, never knowing that behind them a fire burns, and behind the fire the true forms of things exist in a realm of pure being. For Plato, consciousness was caught between two worlds, the world of appearances, the shifting shadows of sense experience, and the world of forms, eternal, unchanging, accessible only through reason, through the mind's ability to perceive truth beyond the testimony of the eyes. He imagined the soul as something that existed before birth, that would exist after death, that carried within it memories of perfect forms glimpsed in a realm beyond this one. And when we recognize beauty, or justice, or goodness, we are remembering, recovering knowledge that was always there, sleeping in the depths of awareness. His student Aristotle, more practical, more interested in the living world around him, took a different view. He saw consciousness emerging from the body, arising from it the way steam rises from water. He cataloged the different types of soul, the nutritive soul of plants, the sensitive soul of animals, the rational soul unique to humans, each one building upon the last. In his work De Anima, on the soul, Aristotle proposed that the mind was like a blank tablet, receiving impressions from the world, forming thoughts through the combination of a sensory experience and reason. Consciousness was not separate from the body, but the form of the body. The way the eye's form is to see, the mind's form is to think. These two visions, Plato's dualism and Aristotle's integration, would echo through centuries, shaping every conversation that followed. In India, around the same time, other thinkers were pursuing the question through different paths. The Upanishads, ancient texts composed between 800 and 200 years before the Common Era, spoke of consciousness as Brahman, the ultimate reality underlying all existence, and Atman, the individual self, which were ultimately one and the same. These philosophers sat in forest groves and developed practices of meditation, turning attention inward with extraordinary precision, mapping the layers of consciousness, the waking state, the dreaming state, the state of dreamless sleep, and beyond these, a fourth state called turiya, pure awareness itself, witnessing all the others. They propose that ordinary consciousness, the everyday experience of being a separate self, was a kind of illusion, maya, a veil drawn over the true nature of reality, and through contemplative practice, through stilling the modifications of the mind, one could glimpse what lay beneath, the vast unchanging awareness in which all experience arose and dissolved. The Buddhist tradition, emerging from the teachings of Siddhartha Gautama in the 5th century before the Common Era, took this inquiry even further, questioning whether there was any permanent self at all, any enduring consciousness that persisted from moment to moment. The Buddha taught that what we call the self, what we call consciousness, is actually a stream of momentary events, arising and passing away faster than we can perceive. Each moment of awareness dependent on causes and conditions, empty of any inherent existence, like a flame passed from candle to candle, appearing continuous, but actually a series of distinct ignitions. This was radical, unsettling, and it pointed towards something that neuroscience would rediscover more than 2,000 years later: the constructed nature of experience, the way consciousness is not a thing, but a process, a verb disguised as a noun. Meanwhile, in China, Confucian and Taoist thinkers approached consciousness through ethics and natural harmony. Mencius, in the 4th century before the Common Era, argued that human nature was inherently good, that moral feelings, once compassion, shame, respect, were as natural as the sprouts of plants pushing through soil. Consciousness was not separate from the natural world, but continuous with it, part of the same flowing pattern. The Tao, the Way, Zhuangzi, the Taoist sage, told stories that dissolved boundaries. His famous butterfly dream, where he dreamed he was a butterfly and waking, could not tell whether he was Zhuangzi, who had dreamed of being a butterfly, or a butterfly now dreaming of being Zhuangzi. This playful paradox pointed to something serious: the instability of perspective, the way consciousness creates reality rather than simply reflecting it. Centuries passed, and the question traveled westward again into the medieval world, where Christian theologians wrestled with how to reconcile Greek philosophy with revealed religion. Augustine of Hippo, in the 4th and 5th centuries of the Common Era, turned Plato's inward turn into a spiritual practice. He explored memory with extraordinary depth, noticing how the mind could hold vast landscapes of experience, could travel backward through time, could know itself, knowing. In his Confessions, Augustine wrote of time as something that exists only in consciousness, the past as memory, the future as expectation, the present as attention, all three existing simultaneously in the soul's eternal now. This was phenomenology before the word existed, the careful examination of experience from the inside. Thomas Aquinas, in the 13th century, integrated Aristotle's naturalism with Christian theology, arguing that the soul was the form of the body, but that the rational soul, unique to humans, was capable of surviving bodily death, capable of contemplating universal truths. He distinguished between different types of knowing: sense perception, imagination, memory, and the intellectus, the higher faculty that could grasp abstract principles, but it was in the Islamic world. In the writings of physicians and philosophers like Avicenna, that consciousness received some of its most penetrating analysis. In the 11th century, Avicenna proposed his famous thought experiment. The floating man, imagine a person, he said, created in an instant, floating in void, with no sensory input, no sight, no sound, no touch. Would this person be aware of their own existence? Avicenna argued yes. Self-awareness was not dependent on the body, not derived from sensation, but immediate, direct. This was consciousness as presence, as the fundamental given from which everything else followed. These medieval thinkers, whether Christian, Muslim, or Jewish, shared a common conviction that consciousness pointed beyond the material world towards something transcendent, eternal, divine, the mind's ability to contemplate infinity, to grasp mathematical truths, to know the good, suggested that it participated in a higher realm, but seeds of change were already planted, and by the 17th century Curie, a new way of thinking was emerging. The scientific revolution, with its emphasis on observation, measurement, and mechanical explanation, would transform the question of consciousness entirely. René Descartes, sitting alone by a fire in 1629, experiencing what he would later describe as a revelation, began to doubt everything he thought he knew. He doubted his senses, which sometimes deceived him. He doubted the external world, which might be a dream. He doubted mathematics, which might be planted in his mind by a deceiving demon. But there was one thing he could not doubt. The fact that he was doubting, the very act of thinking, proved that something was doing the thinking. Cogito ergo sum, I think therefore I am. Consciousness, for Descartes, was the bedrock of certainty, more certain than matter, more certain than the body, more certain than the stars. And from this certainty, he built a system. He divided reality into two substances, res cogitans, think in substance but mind, and res extensa, extended substance, matter. The mind was unextended, immaterial, indivisible, known with perfect transparency to itself. The body was extended, material, divisible, subject to mechanical laws. This dualism, mind separate from matter, consciousness separate from brain, would dominate Western philosophy for centuries and would create a problem that still haunts us, the problem of interaction. If mind and matter are fundamentally different, how do they influence each other? How does a thought, immaterial, move an arm, material? How does light striking the eye, material, become the experience of seeing blue, immaterial? Descartes proposed the pineal gland, a small structure in the center of the brain, as the seat of interaction. But even he knew this was unsatisfying. It didn't solve the problem, only relocated it. His contemporary, Benedict de Spinoza, rejected dualism entirely and proposed instead that mind and matter were two aspects of a single substance, God or nature, viewed from different perspectives. Consciousness and physical processes were perfectly correlated, not because one caused the other, but because they were the same thing, expressed in different languages. This was a vision of extraordinary unity, anticipating later ideas about neutral monism and dual aspect theories. But in Spinoza's own time, it seemed dangerous, heretical, and he was excommunicated from his Jewish community, lived in poverty, grinding lenses to survive. His work published anonymously or after his death. Gottfried Wilhelm Leibniz, another voice from this fertile century, imagined consciousness as something that came in degrees, from the petite perceptions, tiny unconscious experiences that formed the background hum of awareness, to the clear apperceptions, the conscious thoughts we could report and reflect upon. He imagined the universe as composed of infinite monads, simple substances, each one a kind of soul, each one perceiving the entire universe from its own unique perspective. The question was multiplying, branching, becoming more complex with each thinker who touched it. By the 18th century, the question had entered a new phase. The Enlightenment brought with it a fascination with human understanding, with the mechanics of thought, with consciousness, not as a window to the divine, but as something to be studied, mapped, explained. John Locke, in his essay concerning human understanding, published in 1690, returned to Aristotle's image of the mind as a blank slate, tabula rasa. He argued that all knowledge came from experience, that consciousness was built from simple ideas received through sensation, combined and recombined through reflection. There were no innate ideas, no eternal forms remembered from before birth, only the gradual accumulation of experience, layer upon layer, like sediment forming stone. He noticed something curious about personal identity, that it seemed to depend on memory, on the continuity of consciousness across time. You are the same person you were yesterday, not because you have the same body, but because you remember being that person. Consciousness, he wrote, was inseparable from thinking, and personal identity was inseparable from consciousness. George Berkeley, an Irish bishop with radical ideas, pushed empiricism to its limit. He argued that to exist was to be perceived. Esse est percipi. Matter in itself was an abstraction. What we actually experienced was always ideas, sensations, colors and shapes and sounds appearing in consciousness. The external world, if it existed at all, was sustained by being perceived by God, an infinite consciousness that held everything in existence. This seemed absurd to many. Samuel Johnson famously kicked a stone and declared he had refuted it. But Berkeley's point was more subtle. He was asking what we actually know, what we can actually say exists beyond doubt, and finding that consciousness, experience itself, was the only starting point we had. David Hume, perhaps the most skeptical of all, took the empiricist project and dissolved everything into impressions and ideas. He looked inward, searching for this thing called the self, this consciousness that supposedly unified experience, and found nothing, only a bundle of perceptions, arising and passing with no underlying substance, no permanent witness. When I enter most intimately into what I call myself, he wrote, I always stumble on some particular perception or other of heat or cold, light or shade, love or hatred, pain or pleasure. I never can catch myself at any time without a perception, and never can observe anything but the perception. This anticipation of the Buddhist doctrine of no self, emerging from the heart of Scottish Enlightenment philosophy, pointed toward a deep truth about the constructed nature of consciousness, the way what seems most solid, most undeniable, the sense of being a continuous self, might itself be an illusion, a story consciousness tells about itself, Immanuel Kant, writing in 1781 in his Critique of Pure Reason, tried to find a middle way between rationalism and empiricism, between the idea that consciousness imposed order on the world and the idea that it passively received impressions. He argued that the mind was not a blank slate, but came equipped with categories, with forms of intuition, space and time, with principles of understanding that structured experience. We never perceive things as they are in themselves, he said, only as they appear to us, filtered through the necessary structures of consciousness. The mind was active, creative, bringing order to the chaos of sensation, making experience possible. And there was something he called the transcendental unity of apperception, the necessary condition for consciousness itself. The fact that all my experiences must be accompanied by the possibility of thinking, I think. This was not the empirical self, the bundle of perceptions Hume described, but the formal condition that made a unified consciousness possible, the invisible thread holding everything together. The 19th century arrived, and with it, new tools, new methods, new ways of investigating consciousness. Psychology was beginning to separate from philosophy, to become an experimental science. Wilhelm Wundt, in 1879, established the first laboratory dedicated to experimental psychology in Leipzig. He trained observers to report their conscious experiences with precision, to break down perceptions into their component sensations, to measure reaction times, to map the structure of awareness. This was introspection made systematic, consciousness studying itself under controlled conditions. His student Edward Titchener brought these methods to America, developing what he called structuralism, the attempt to identify the basic elements of consciousness, sensations, images, feelings, and the rules by which they combined. It was chemistry applied to the mind, seeking the periodic table of experience. But William James, writing in his masterwork, The Principles of Psychology, published in 1890, rejected this atomistic approach. Consciousness, he argued, was not a collection of separate elements, but a stream, a continuous flow. Each moment of awareness was unique, could never be repeated, was colored by everything that came before. Consciousness was personal, changing, continuous, and selective, always choosing, always focusing, always flowing forward like a river. He spoke of the fringe of consciousness, the dim awareness surrounding the bright center of attention, the way meanings and feelings hovered at the edges of thought. He noticed the tip of the tongue phenomenon, that strange experience of knowing you know something without being able to recall it. These observations, careful and honest, opened up the phenomenology of consciousness in new ways. James also grappled with the self, distinguishing between the I and the me, between consciousness as knower and consciousness as known, between the subject and the object of awareness. And he could not resolve it, could not say which was primary, only that both seemed necessary, that consciousness required this strange doubling, this capacity to be both witness and witnessed. In Vienna, at the same time, Sigmund Freud was developing a very different picture of consciousness. For Freud, what we were aware of was only the surface, the tip of an iceberg. Beneath consciousness lay the preconscious thoughts and memories that could be brought to awareness, and beneath that, the unconscious, a vast realm of repressed desires, forgotten traumas, primitive drives that shaped behavior without ever entering awareness. Consciousness, in this view, was not the master of the house, but a spokesperson, rationalizing decisions made elsewhere, defending against truths too painful to acknowledge. The ego, the conscious self, was caught between the demands of the id, the superego, and reality itself, always negotiating, always compromising. This was deeply unsettling. It suggested that consciousness was not transparent to itself, that we could be mistaken about our own motivations, that the inner light was actually full of shadows. Freud's talking cure, psychoanalysis, was an attempt to bring the unconscious into consciousness, to make the hidden visible through free association, through dream interpretation, through the analysis of slips and symptoms. While Freud was exploring the depths, other researchers were mapping the brain. In 1861, Paul Broca identified a region in the left frontal lobe that, when damaged, impaired the ability to speak. This was revolutionary. It showed that specific mental functions were localized in specific brain regions, that consciousness was tied to neural architecture. Carl Wernicke discovered another area in the temporal lobe whose damage impaired language comprehension, and slowly, case by case, the map of the brain began to take shape. Motor cortex here, sensory cortex there, visual processing in the back, language on the left. The mind was becoming physical, touchable, visible in the folds of gray matter. But how did this physical stuff, neurons and synapses and electrical signals, become experience, become the taste of coffee, the memory of childhood, the understanding of a sentence? This was the hard problem, even if no one called it that yet. In the early 20th century, behaviorism rose to dominance, especially in America. John Watson and later B.F. Skinner argued that psychology should study only observable behavior, not consciousness, which was private, unverifiable, unscientific. Consciousness was a black box, and science should concern itself only with inputs and outputs, stimuli and responses. For decades, consciousness nearly disappeared from scientific discourse, replaced by talk of conditioning, reinforcement schedules, stimulus response chains. The inner life was dismissed as epiphenomenal, a side effect with no causal power, or worse, as a kind of category error, a confusion of language, as something that would dissolve once we understood behavior properly. But consciousness didn't stay buried. In philosophy, phenomenology was developing a rigorous method for studying experience from the inside. Edmund Husserl, working in Germany in the early 1900s, argued that we needed to bracket our assumptions about the external world to attend purely to phenomena, to things as they appeared in consciousness. He described the intentional structure of consciousness, the fact that consciousness was always consciousness of something, always directed, always about. Even imagination, memory, emotion were intentional, pointed towards objects, real or imagined, present or absent. His student Martin Heidegger shifted the focus from consciousness to existence, to Dasein, being there, the human way of being in the world. For Heidegger, we were not primarily detached observers, but beings thrown into a world, already engaged, already caring, already immersed in projects and meanings. Consciousness was not a thing inside the head, but a way of being related to everything around us. Maurice Merleau-Ponty, in mid-century France, brought the body back into phenomenology. He argued that consciousness was embodied. That perception was not the passive reception of sense data, but an active engagement with the world through a living body. The body was not an object we possessed, but the subject we were, like our perspective on the world, the 0 point from which all experience unfolded. These phenomenologists were describing consciousness with extraordinary precision, but from the inside, without reducing it to brain states or behaviors. They were taking seriously the lived experience, the qualitative feel of awareness, the texture of being. And then, in the middle of the 20th century, everything changed again. The computer was invented, and suddenly there was a new metaphor, a new way of thinking about mind. The mind, some began to suggest, might be like software running on the hardware of the brain, information processing, computation, algorithms transforming inputs into outputs. This was the cognitive revolution, and it brought consciousness back into scientific respectability, though in a very different form. Alan Turing, in 1950, proposed his famous test. If a machine could respond to questions in a way indistinguishable from a human, would we say it was conscious? He didn't answer the question, only suggested that perhaps the question itself was misguided, that consciousness might not be some special substance, but something that emerged from the right kind of information processing. The brain, neuroscientists began to discover, was far more complex than anyone had imagined. 100 billion neurons, each connected to thousands of others, forming networks of staggering intricacy. Each neuron firing or not firing based on inputs from its neighbors, patterns of activity cascading through the network, creating representations, memories, decisions. In the 1960s and 70s, researchers began mapping visual processing. David Hubel and Torsten Wiesel discovered cells in the visual cortex that responded to specific features, edges at particular angles, movement in particular directions. The brain was decomposing the visual scene, analyzing it in parallel across multiple pathways, and somehow, from all this distributed processing, the unified experience of seeing emerged. But how? That remained mysterious. Francis Crick, co-discoverer of the structure of DNA, turned his attention to consciousness in the 1980s. Along with Christoph Koch, he proposed that consciousness might be associated with specific neural mechanisms, perhaps synchronized firing at 40 hertz, perhaps activity in specific brain regions like the thalamus or the claustrum. They argued that consciousness was a scientific problem, not a philosophical one, and that it could be solved by finding the neural correlates of consciousness, the minimal set of brain events sufficient for a particular conscious experience. This was the beginning of a new era, an explosion of research into consciousness using brain imaging, electroencephalography, recordings from individual neurons. The tools were finally catching up to the question. Thomas Nagel, in a famous paper from 1974, asked what it was like to be a bat. Bats navigate by echolocation, perceiving the world through reflected sound waves. We can describe the mechanism, can explain the physics and the neuroscience, but we cannot know what it feels like from the inside. The qualitative character of bat experience, this what it is like, This subjective feel Nagel called phenomenal consciousness, and he argued it could not be reduced to physical descriptions, no matter how complete. This was the explanatory gap, the gap between third-person objective descriptions of brain processes and first-person subjective experiences, between neural firing patterns and the redness of red, the painfulness of pain, the ineffable whatness of experience. David Chalmers, in 1995, crystallized this into the hard problem of consciousness. There were easy problems, he said, problems that were difficult but tractable. How does the brain integrate information? How does it control behavior? How does attention work? These could be solved by standard neuroscience methods, but the hard problem was different. Why is there something it is like to be conscious at all? Why doesn't all this information processing happen in the dark? Why is there an inner light, an experiential dimension? This seemed to resist explanation in physical terms. Some philosophers embraced property dualism, the idea that consciousness was a fundamental property of nature, like mass or charge, not reducible to anything more basic. When matter is organized in the right way, in brains or perhaps in other complex systems, consciousness emerges as a basic fact. Others proposed panpsychism, the ancient idea that consciousness, in some primitive form, might be everywhere, that even electrons might have some tiny degree of experience, and that complex consciousness like ours emerged from the combination of simpler forms. This sounded mystical, but some argued it was more parsimonious than saying consciousness suddenly appeared when matter reached a certain complexity. Daniel Dennett, taking the opposite approach, argued that the hard problem was an illusion, that consciousness was not what it seemed to be from the inside, that there was no privileged central theater where experience happened, no Cartesian theater, but rather multiple parallel processes creating the appearance of unity. Consciousness was not a thing, but a collection of cognitive tricks, of narratives the brain told itself. When you understood it properly, the mystery dissolved. This became known as eliminativism or illusionism, the view that phenomenal consciousness, qualia, the what it's likeness, didn't really exist in the way we thought it did. It was a user illusion, like the desktop interface on a computer, useful but not real. The debates grew heated. Philosophers and scientists at conference, arguing late into the night about zombies, philosophical thought experiments about beings physically identical to us, but with no inner experience, about inverted spectra, whether your red might be my green with no way to tell, about Mary the color scientist who knew everything physical about color but had never seen it. Would she learn something new when she finally saw red? These seemed like parlor games to some, but to others they pointed to something genuine, something that standard physical explanation couldn't capture. Meanwhile, neuroscience continued its relentless mapping. In the 1990s, researchers discovered the neural correlates of binocular rivalry, when each eye sees a different image and consciousness alternates between them. The input stays constant, but awareness switches. By comparing brain activity during each percept, scientists could identify regions associated with conscious experience itself, not just sensory processing. They found that consciousness seemed to require widespread brain activity, not just local processing in sensory areas. The global workspace theory proposed by Bernard Bars, suggested that consciousness was like a theater, where information that reached the global workspace became available to many different cognitive processes, became reportable, became consciously experienced. Giulio Tononi developed integrated information theory, proposing that consciousness was identical to integrated information that couldn't be decomposed into independent parts. He gave it a mathematical measure, phi, and suggested that any system with high phi would be conscious, whether biological or artificial. This was controversial, but it was testable. It made predictions. It could be applied to patients in vegetative states to measure levels of consciousness, to distinguish between minimally conscious and unconscious states. The study of altered states exploded. Researchers gave subjects psychedelics, psilocybin, LSD, and scanned their brains. They found decreased activity in the default mode network, the brain regions active during rest, during self-referential thought. The boundaries of the self seemed to dissolve, the sense of being a separate observer, and subjects reported experiences of unity, of ego death, of consciousness expanding beyond its normal confines. Meditation, too, became a subject of neuroscience. Long-term meditators showed changes in brain structure, in attention networks, in emotional regulation, states described in ancient contemplative texts. Jhanas, samadhi, could be correlated with specific patterns of brain activity. The science and the contemplative traditions were beginning to speak to each other. Anil Seth proposed that consciousness was controlled hallucination, that the brain was constantly generating predictions about the world and updating them based on sensory input. What we experience was not the world itself, but the brain's best guess about what's out there. Perception was prediction, and consciousness was the brain's model of itself and its environment. This predictive processing framework could explain many puzzles. Why ambiguous figures flip, why expectations shape perception, why attention is selective. The brain was not passively receiving the world, but actively constructing it, moment by moment. And then, in the 21st century, artificial intelligence began to advance at unprecedented speed. Neural networks with millions or billions of parameters, learning to recognize images, translate languages, play games at superhuman levels, large language models that could engage in conversation, answer questions, generate text that seemed thoughtful, creative, aware. The question became urgent again, in a new form. Could these systems be conscious? They processed information, integrated it across many layers, produced sophisticated outputs, but was there something it was like to be GPT-3 or GPT-4? Was there an inner experience, or just computation in the dark? Some argued that without the right architecture, without the biological substrate, without embodiment, there could be no consciousness. Others said consciousness was substrate independent, that if the information processing was sufficiently complex and integrated, consciousness would emerge, whether in carbon or silicon. The tests we had asking about subjective experience required language, required the ability to report, but maybe that was circular. Maybe consciousness could exist without report. Maybe some systems were conscious but couldn't tell us. Philosophers proposed new frameworks, illusionist functionalism, higher order theories where consciousness required awareness of awareness, global workspace, theories where consciousness was widespread access, local recurrency theories where it was reverberant processing in sensory cortex. Each theory made different predictions about what would be conscious and what wouldn't, about when consciousness appeared in evolution, in development, about whether AI could be conscious, about whether consciousness could exist without attention. The field had become vast, sprawling. Neuroscientists, philosophers, computer scientists, physicists, all approaching the same mystery from different angles. The tools were better than ever. Brain imaging with millimeter precision, computational models of neural networks, theoretical frameworks drawing on information theory, quantum mechanics, complexity science, and yet the basic question remained, soft and persistent as always. What is consciousness? How does the physical world give rise to inner experience? Why is there something it is like to be anything at all? Some days it felt like progress was being made, like the pieces were starting to fit together. Other days it felt like the mystery was as deep as ever, like every answer opened new questions, like understanding receded as quickly as we approached. But perhaps that was fitting. Perhaps consciousness, by its nature, would always remain partially mysterious to itself, like an eye that cannot see itself seeing, like a hand that cannot grasp itself. The history stretches out behind, like a long road walked at dusk. All those thinkers, all those theories, all those attempts to understand the inner light. And now, having walked through centuries, through laboratories and monasteries, through arguments and experiments, through all these brilliant attempts to understand, I find myself drawn deeper still, not into history, but into the questions themselves, the ones that pulse beneath all the theories. There is something about consciousness that resists capture, that slips away the moment you try to pin it down, like trying to see the moment when you fall asleep. The transition is always missed, always happening in the gap between attention. The philosopher Maurice Merleau-Ponty noticed this, that consciousness was always in a kind of recession from itself. We can attend to our thoughts, but the attending itself remains in shadow. We can observe our observing, but something is always doing the observing, receding backward infinitely, like standing between two mirrors. And perhaps this is essential. Perhaps consciousness must be transparent to itself, must be the clearing in which everything else appears. If we could see it directly, objectify it completely, it would no longer be consciousness, but just another object in the field. The mystics understood this. They spoke of consciousness as emptiness, not as a void, but as pure potential, the space in which all forms arise. Meister Eckhart, the 14th century Christian mystic, spoke of the ground of the soul, the Godhead beyond God, the silent awareness prior to all distinction. The Zen tradition points to this with the koan. What is your original face before your parents were born? The question is unanswerable by thought, because thought itself appears within consciousness. The answer is not in finding something, but in recognizing what has always been there, the witnessing presence that was never born and will never die. This is not science, but it maps onto something science keeps discovering, that consciousness seems to be fundamental, irreducible, present at the base of all experience. The neuroscientist Christoph Koch, after decades of research, found himself drawn toward panpsychism, the idea that consciousness might be intrinsic to matter itself, not because neurons have souls, but because experience might be woven into the fabric of reality at every level. Physics, too, has encountered strange facts. The observer effect in quantum mechanics, where the act of measurement seems to collapse the wave function to bring potentiality into actuality. John Wheeler, the physicist, proposed the participatory universe, where consciousness was not a late arrival, but essential to the cosmos from the beginning, observing itself into existence. This is speculative, controversial, but it points to how deeply consciousness is entangled with reality, how observation and existence seem inseparable, how the universe seems to require witnesses. And then there is time. Consciousness is always now, always present. Memory is experienced now. Anticipation is experienced now. Even the sense of duration, of time passing, happens in the eternal present moment of awareness. Augustine saw this, that time existed only in the soul. But modern neuroscience has discovered something similar, that the brain constructs the experience of now, that there is no single moment when all sensory information arrives. Visual processing takes different amounts of time for color, motion, form, and yet they are bound together into a unified present. The spacious present, William James called it, the thick now of consciousness, a few hundred milliseconds where everything feels simultaneous. But what binds it? What makes all these separate processes, happening at different times in different regions, feel like one coherent moment? This is the binding problem, and no one has solved it. There is no place in the brain where it all comes together, no homunculus in the theater watching the show, and yet here we are, experiencing unity, coherence, a single stream. The philosopher Thomas Metzinger suggests this is the ego tunnel, a model the brain creates, giving the illusion of a unified self moving through time. But the model is so convincing, so totalizing, that we cannot step outside it. We are caught in the tunnel, mistaking the map for the territory. Or perhaps the unity is real, not located in space, but existing as a higher order property, the way a symphony is real, even though it's not located in any single instrument. Consciousness as an emergent phenomenon arising from complexity, from the right kind of integration, irreducible to its parts, but dependent on them. The Buddhist philosopher Nagarjuna in the 2nd century taught that consciousness was empty of inherent existence, not because it didn't exist at all, but because it existed only relationally, only in dependence on conditions. When the conditions change, consciousness changes. When the conditions cease, consciousness ceases. Nothing permanent, nothing independent, just patterns arising and dissolving. And modern neuroscience echoes this. Consciousness fluctuates, levels rise and fall with arousal, with attention, with the sleep-wake cycle. Under anesthesia, it vanishes, seemingly completely. Where does it go, and how does it return? Identical and yet never quite the same. Split brain patients whose corpus callosum has been severed seem to have two separate streams of consciousness. The left hemisphere can speak, can report experience. The right hemisphere cannot speak, but can respond non-verbally, showing knowledge the left hemisphere denies. Are there two consciousnesses in one skull, or one consciousness that thinks it's unified? These cases trouble our assumptions, show how fragile and constructed the sense of unity is. Consciousness expands and contracts. In deep meditation, some report a sense of boundlessness, of awareness without content, pure subjectivity with no object. Others report the opposite, absorption so complete that the self disappears, becoming the music, the breath, the movement, subject and object dissolving into flow. Psychedelics reveal how radically consciousness can be altered. Synesthesia, where colors have sounds, where music has textures, the normal categories break down, revealing how much of ordinary experience is constructed, filtered, shaped by expectations and models, and what of other minds. We assume other humans are conscious because they are like us, but where do we draw the line? Are great apes conscious? Almost certainly. Dogs, probably. Fish, maybe. Insects, less clear. And what about AI? What about future systems far more complex than anything today? We have no consciousness meter, no way to measure it from outside, only behavior, only inference. And if consciousness is something over and above information processing, we may never be able to tell for certain. This is the problem of other minds, ancient and unsolved. Each of us knows consciousness directly, immediately, in our own case, but everywhere else it's a leap of faith. Reasonable, necessary, but ultimately unverifiable. Perhaps consciousness comes in degrees. Perhaps it's not binary, not present or absent, but a continuum from the dim awareness of simple systems to the rich inner world of humans, to possibilities we cannot yet imagine, forms of consciousness so different from ours that we wouldn't recognize them. The universe, in this view, is not dead matter with occasional pockets of awareness, but a spectrum, a gradient, consciousness in different modes and intensities, woven through everything. And so the question remains open. After all these centuries, after all this inquiry, the mystery intact, dignified, beautiful in its resistance. I think of all those thinkers sitting in lamplight, in monasteries, in laboratories, turning the question over, each one adding a piece, a perspective, a method, the accumulated wisdom like layers of sediment forming something solid enough to stand on, deep enough to contain rivers, and perhaps that's enough. Perhaps the value is not in solving the mystery, but in the looking, in the sustained attention to the deepest fact of existence, that we are here, that we are aware, that being conscious is the most ordinary and most extraordinary thing. The night has deepened around these thoughts. The questions that seemed so urgent at the beginning have softened, become companions rather than puzzles demanding solution. Consciousness, this strange inner light, this capacity to know and be known. It is the ocean we swim in, the air we breathe, so close we cannot see it, so intimate we cannot escape it. And maybe it will always be this way. Maybe consciousness will always remain partially mysterious to itself, the eye that cannot see itself, the light that illuminates everything except its own source. The philosophers will continue their work, building arguments, testing intuitions. The scientists will continue their work, mapping neurons, measuring correlations, finding mechanisms. The contemplatives will continue their work, sitting in silence, watching the mind, dissolving into awareness itself, each path revealing something true, each perspective partial but necessary, together forming a kind of hologram where every angle shows the whole from a different view. I imagine consciousness as it might have first appeared in the universe, billions of years ago, in the first organisms with nervous systems, a dim flicker, a primitive sensing, the beginning of inwardness, and then slowly, through evolution, through complexity, becoming richer, deeper, more layered, until something could reflect on its own existence, could ask what it is, could wonder, and perhaps it continues. Perhaps consciousness is still evolving, still becoming, moving toward forms we cannot conceive. The universe waking up, layer by layer, becoming aware of itself through countless eyes, countless minds. We are each of us that awakening. We are how the cosmos knows itself, how matter becomes mind, how the physical becomes experiential, however it works, whatever the mechanism, whatever the explanation, this fact remains astonishing, undeniable. The words are fading now, like footprints in sand as the tide comes in, the questions dissolving back into the silence from which they came. Somewhere in this quiet moment, consciousness continues. In you, in me, in the world, doing what it has always done, being aware, experiencing, witnessing the eternal now, the infinite present, the mystery that is no mystery because it is what we are. And perhaps that is the deepest answer. Not an explanation, but a recognition. Not solving the problem, but becoming it. Being consciousness rather than understanding it. The night holds this gently, without resolution. The stars continue in their courses. The world turns. And awareness, this fundamental fact, this groundless ground, remains quiet, luminous, empty and full, nowhere and everywhere, the light that needs no lamp, the knowing that requires no knower. Let the questions rest now. Let them settle like dust after wind. They will return. They always do. But for this moment, let there be only the soft presence of being, the simple fact of awareness, watching thoughts arise like birds taking flight at dawn and dissolving, leaving only the sky. There is a kind of stillness that settles over the world when familiar things begin to shimmer, when what seemed solid reveals itself to be something else entirely, something vast and uncertain and strangely beautiful. Tonight, I find myself drawn into that shimmer, into the heart of a revolution that began not with thunder, but with whispers, quiet observations in laboratories lit by gas lamps and gentle lamplight, questions asked in the margins of equations, puzzles that refuse to behave. The quantum world, this realm beneath the surface of everything we touch and see, didn't announce itself with fanfare. It crept into human awareness slowly, reluctantly, like morning mist revealing an unfamiliar landscape that had been there all along. I imagine walking through a museum late in the evening when the crowds have dispersed and the halls echo with footsteps that aren't quite my own. The exhibits here are not paintings or sculptures, but ideas, fragile and revolutionary, mounted carefully behind glass. In the first room, there is darkness, the comfortable darkness of the 19th century, when matter seemed dependable, when atoms, if they existed at all, were thought to be tiny billiard balls, solid and predictable, rolling through space according to laws that felt almost musical in their precision. But even then, even in that confident age, there were cracks forming, anomalies that didn't fit the elegant theories, light that behaved strangely when passed through prisms, metals that glowed with colors that shifted as they grew hotter, radiation pouring from substances that seemed to burn without fuel or flame. I can almost see the laboratories of that time, wooden benches cluttered with glass apparatus, the sharp smell of chemicals, the scratch of pen on paper as someone records an observation that refuses to make sense. Again and again, the same impossible result. The quantum story begins, I think, in the borderlands between light and heat, in the strange glow of objects warming in furnaces, black body radiation, they called it, this light emitted by heated objects, and it should have been simple, a smooth curve rising and falling according to well-understood principles, but it wasn't simple. The equations broke down, predicting infinite energy at certain wavelengths, an ultraviolet catastrophe that would have meant the universe consuming itself in radiation. And yet, the universe remained calm and indifferent to the mathematics that tried to describe it. Someone had to step into that contradiction to suggest something uncomfortable, something that violated every intuition about how nature should work. Energy, perhaps, didn't flow smoothly like water. Perhaps it came in packets, discrete bundles, quanta, the way coins are separate from one another, even though we imagine money as a continuous quantity. It was 1899 turning into 1900, a threshold between centuries, and Max Planck, working in Berlin, introduced this idea almost apologetically as a mathematical trick, a convenience that happened to match the experimental data. He didn't believe it was real, not at first, not in his bones, but the quantum had arrived, whether anyone believed in it or not. I imagine those early years as a landscape where the ground beneath everyone's feet had become uncertain, where stepping forward required a kind of courage that had nothing to do with physical danger and everything to do with releasing certainty, letting go of the world as it had always been understood. Light itself became the next mystery, the next impossible thing. For centuries, light had been argued over. Was it wave or particle, undulation in some invisible medium, or a stream of tiny projectiles fired across space? By the late 19th century, the wave theory seemed to have won. Experiments showed interference patterns, diffraction, all the hallmarks of waves spreading and overlapping. And yet, when light struck certain metals, it knocked electrons loose. And the details of this photoelectric effect made no sense if light was purely a wave. The energy of the ejected electrons depended on the color of the light, not its intensity. Bright red light did nothing, while dim violet light freed electrons immediately. Albert Einstein, still unknown, working in a patent office in Bern, read Planck's work and took it seriously, more seriously perhaps than Planck himself. In 1905, that miraculous year, Einstein proposed that light itself was quantized, that it traveled in packets, photons, each carrying a specific amount of energy determined by its frequency, its color, the wave-particle duality. This impossible doubleness had entered the world. I think of how it must have felt to be young and unknown and certain of something the entire scientific establishment considered absurd, to write papers in spare moments, and to know somehow that the universe was stranger and more beautiful than anyone had dared imagine. The quantum world was opening like a flower in the dark, petal by petal, revealing symmetries no one had expected and contradictions no one knew how to resolve. The story gathers momentum now, like water finding its path downhill. inevitable, unstoppable, though no one at the time could have predicted where it would lead. Niels Bohr arrives in this narrative like a character stepping onto a stage, a young Danish physicist with a football player's build and a philosopher's temperament, drawn to England, to the laboratories where atoms were being probed and questioned. In 1911, he found himself in Ernest Rutherford's lab in Manchester, where experiments had recently shattered the comfortable image of atoms as solid spheres. Rutherford had fired particles at gold foil, expecting them to pass through with barely a deflection, like bullets through tissue paper. But some particles bounced straight back, impossibly, as if they'd struck something incredibly dense and small, a nucleus, a tiny core at the atom's heart, with electrons somehow orbiting around it, like planets around a distant sun. The planetary model was beautiful, intuitive, and completely unstable according to classical physics. Orbiting electrons should radiate energy continuously, spiraling inward in a fraction of a second, collapsing into the nucleus in a catastrophic rush. Yet atoms persisted, stable, emitting light only at specific frequencies, like musical instruments that could play only certain notes. Never the tones in between. Bohr took the quantum idea, still strange and uncomfortable, and applied it with daring simplicity. What if electrons could orbit only at certain distances, certain energy levels, and nowhere in between? What if they jumped from one orbit to another instantaneously, without passing through the space between emitting or absorbing a photon with each quantum leap? The Bohr model emerged in 1913, and suddenly the spectrum of hydrogen made sense. Those precise lines of color, those forbidden wavelengths, they were the signatures of electrons jumping between allowed orbits, climbing and falling through discrete steps. It was a hybrid thing, this model, part classical, part quantum, a bridge between worlds, and it worked, at least for hydrogen, predicting spectral lines with stunning accuracy. But it was also clearly incomplete, a sketch rather than a portrait, and Bohr knew it, even as others celebrated his success. He understood that deeper principles waited to be discovered. The First World War interrupted everything, scattering scientists across battlefields and weapons laboratories, turning minds that had contemplated the nature of light toward poison gas and explosives. The quantum revolution paused, held its breath, while the world tore itself apart. When the war ended, a generation emerged traumatized, disillusioned, ready to question everything, including the foundations of knowledge itself. And quantum mechanics found fertile ground in that soil of uncertainty. The early 1920s brought a strange parade of discoveries, each more peculiar than the last. Louis de Broglie, a French aristocrat turned physicist, proposed in 1923 that if light could behave as both wave and particle, perhaps matter could do the same. Perhaps electrons, previously thought of as tiny particles, also had a wavelength, a wave nature. It seemed absurd. Matter waves, but the mathematics was elegant, and when experiments were finally performed, firing electrons at crystals, they produced interference patterns, the unmistakable signature of waves. Matter itself was blurring, becoming uncertain. Wolfgang Pauli, brilliant and caustic, tormented by his own precision, discovered in 1924 that no two electrons could occupy the same quantum state simultaneously. The exclusion principle, a rule that had no classical analog, nothing in the familiar world to compare it to, and yet this principle explained the entire periodic table, the architecture of chemistry, why atoms built up in shells, why elements had the properties they did. The old quantum theory, with its mixture of classical orbits and quantum jumps, was clearly breaking down, giving correct answers for the wrong reasons, or for no comprehensible reason at all. Something more fundamental was needed. I imagine the state of mind in those years, the confusion mixed with exhilaration, working with tools that functioned but made no sense, like using a machine whose workings were hidden, whose outputs were reliable, but whose mechanism remained mysterious. Two young men, barely in their 20s, would break through the confusion almost simultaneously, approaching from different directions, finding the same truth beneath different mathematical languages. Werner Heisenberg, intense, allergic to pollen and philosophy in equal measure, working on the island of Helgoland in the spring of 1925 to escape hay fever, abandoned all attempts to visualize atomic processes. He stopped trying to picture electrons in orbits, stopped asking what they looked like or where they were. Instead, he focused only on observable quantities, on the light emitted or absorbed, on the frequencies and intensities that could actually be measured, and he constructed a mathematical framework, matrix mechanics, where physical quantities became tables of numbers, matrices that didn't commute, where the order of multiplication mattered. It was abstract, austere, almost violently divorced from intuition, and it worked. It predicted the hydrogen spectrum, the helium spectrum, phenomena that had resisted all previous attempts at explanation. Almost simultaneously, Erwin Schrödinger, older, steeped in classical physics and philosophy, took de Broglie's matter waves seriously. He asked what equation these waves might obey, and in an extraordinary burst of creativity over the Christmas holiday of 1925, staying at a villa in the Alps with a mysterious companion whose identity he never revealed, he derived his wave equation. The Schrödinger equation was beautiful, familiar in form, resembling wave equations from classical physics, and when applied to the hydrogen atom, it produced the same energy levels, the same spectral lines as Bohr's model, but derived from deeper principles, from a wave function that somehow encoded everything that could be known about a quantum system. For a brief moment, it seemed that the quantum world might be tamed, reduced to waves, strange waves perhaps, but waves nonetheless, something physicists could visualize and understand. But the wave function itself was peculiar. It wasn't a physical wave in space. It lived in an abstract mathematical realm, and for systems with multiple particles, it existed in high-dimensional spaces that couldn't be visualized at all. And then there was the question of what the wave function meant, what it represented. Schrödinger thought perhaps it described a smeared-out electron spread through space like a cloud, but that interpretation crumbled under scrutiny. When electrons were detected, they always appeared as points, never smeared, never divided. Max Born, working in Göttingen, proposed the answer that would become orthodox. The wave function didn't represent physical reality directly. It represented probability, the probability of finding an electron at a particular location if you looked. The act of measurement somehow collapsed the wave function, forcing the electron to choose a definite position from among the many possibilities it had embodied. This was disturbing. Measurement creating reality rather than revealing it. Observation playing an active role rather than remaining passive. The quantum world seemed to exist in a haze of possibility until someone looked at it. Heisenberg pushed further, examining the process of measurement itself, asking what it meant to determine an electron's position or momentum, and he discovered in 1927 his famous uncertainty principle, not merely a limitation of experimental technique, but a fundamental feature of nature. The more precisely you determined a particle's position, the less precisely you could know its momentum, and vice versa. There was a trade-off, an irreducible uncertainty, encoded in the mathematics, guaranteed by the non-commuting nature of quantum operators. It wasn't that the electron had a definite position and momentum that we simply couldn't measure. It was that these properties didn't exist simultaneously in the way classical physics assumed. Asking for both was like asking whether a wave was more fundamentally at a point or spread out. The question itself was wrong. The Copenhagen interpretation crystallized around Bohr and Heisenberg in those years, a philosophical framework for understanding or accepting the strangeness. It held that quantum mechanics was complete, that the probabilistic nature wasn't hiding some deeper deterministic reality, and that the act of measurement was fundamental, collapsing possibilities into actualities. Bohr spoke of complementarity, the idea that wave and particle were complementary descriptions, mutually exclusive but both necessary, like two languages describing the same ineffable thing. You could use one or the other depending on your experimental setup, but never both simultaneously. The mathematics worked flawlessly. Predictions matched experiments with extraordinary precision, but the meaning remained elusive, slippery. Different physicists held different interpretations, argued late into the night, and still went to their laboratories the next morning to calculate and measure. Not everyone accepted the new orthodoxy. Albert Einstein, by now famous, venerated, found the probabilistic interpretation deeply unsatisfying. He couldn't believe that God played dice with the universe, that nature was fundamentally indeterminate. Surely, he thought, quantum mechanics was incomplete, a statistical description of some deeper reality where particles had definite properties even when unobserved. The great debates began, Einstein versus Bohr, carried on in letters and lectures and the famous Solvay conferences where the greatest minds gathered. Einstein would propose thought experiments designed to show contradictions or incompleteness in quantum mechanics, and Bohr would respond, often staying up all night to find the flaw in Einstein's reasoning. The subtle way quantum principles preserved consistency. In 1935, Einstein, working with Boris Podolsky and Nathan Rosen, published a paper describing what seemed like a fatal problem, a paradox. If quantum mechanics was complete and two particles became entangled, correlated in their quantum states, then measuring one particle would instantly determine the state of the other, no matter how far apart they were. Faster than light, spooky action at a distance, Einstein called it. Surely this proved quantum mechanics was incomplete. Surely particles had hidden properties all along. Bohr defended quantum mechanics, arguing that entangled particles couldn't be treated as separate systems, that the whole was more fundamental than the parts. But the issue remained unresolved, a philosophical puzzle rather than an experimental question, or so it seemed for decades. The foundations were laid now, the mathematical structure complete, even if its interpretation remained contested, and attention turned from philosophy to application, from asking what quantum mechanics meant to asking what it could do. The 1930s and 40s became a golden age of application, quantum mechanics transforming from philosophical puzzle into practical tool. The Schrödinger equation could be solved, approximately at first, then with increasing sophistication for atoms and molecules, revealing the architecture of chemical bonds, the dance of electrons that held matter together. Paul Dirac had already unified quantum mechanics with special relativity in 1928, deriving an equation that naturally produced electron spin and predicted antimatter, a mirror world of particles with opposite charge. The positron was discovered 4 years later, exactly as Dirac's mathematics foretold, reality conforming to the equations with almost magical precision. I think of those years as a time when the periodic table finally made sense, when chemists could understand why carbon formed 4 bonds, why noble gases refused to react, why metals conducted electricity while insulators didn't, all of it flowing from the wave functions of electrons, from the exclusion principle and the quantum rules governing their behavior. The atomic nucleus itself became a new frontier. Neutrons were discovered in 1932 by James Chadwick, and suddenly the nucleus wasn't just protons packed impossibly close. It contained neutrons too, neutral particles bound by a force stronger than electromagnetism, the strong nuclear force, operating only at distances smaller than an atomic nucleus. Quantum mechanics explained radioactive decay, the way uranium nuclei spontaneously split, alpha particles tunneling through energy barriers they shouldn't classically be able to surmount, quantum tunneling, another impossibility made routine, particles passing through walls by existing as waves, materializing on the other side. When nuclear fission was discovered in 1938, when Lisa Meitner and Otto Frisch realized that uranium nuclei could split into lighter elements, releasing enormous energy, the quantum world suddenly had geopolitical implications. The mathematics of wave functions and probability amplitudes became entangled with the machinery of war. The Manhattan Project pulled physicists from universities and laboratories, set them to work calculating neutron cross-sections, chain reaction dynamics, the critical mass needed for a uranium or plutonium bomb, quantum mechanics, barely 20 years old as a complete theory, was being used to design weapons of unprecedented destructive power. I imagine the strange doubling of consciousness this must have required, working with equations of extraordinary beauty, describing the most fundamental aspects of nature, while knowing the purpose was to incinerate cities, to force matter to release the binding energy that held nuclei together. After the war ended, after Hiroshima and Nagasaki, the physicists scattered again, many returning to pure research, carrying guilt and knowledge in equal measure, and quantum mechanics entered a new phase, simultaneously celebrated and applied with little concern for the interpretational puzzles that had so troubled the founders. Solid-state physics emerged as a discipline, applying quantum mechanics to crystals, to the regular arrays of atoms in metals and semiconductors, understanding how electrons moved through these structures, why some materials conducted, others insulated, still others fell somewhere in between. The transistor was invented at Bell Labs in 1947, a quantum mechanical device, exploiting the band structure of semiconductors, the way quantum mechanics created allowed and forbidden energy ranges for electrons in crystalline solids. Within a decade, transistors began replacing vacuum tubes, shrinking, becoming cheaper, more reliable, launching the electronics revolution that would reshape human civilization. Lasers followed in 1960. Light amplification by stimulated emission of radiation, another quantum phenomenon, atoms excited to higher energy states, then triggered to emit photons in perfect synchrony, coherent light, all the waves marching in lockstep, monochromatic, directional, intense enough to cut through steel or carry information through fiber optic cables. Every technology of the late 20th century rested on quantum foundations, even if engineers didn't always think in those terms. The computer on which designs were drafted, the sensors in medical imaging devices, the atomic clocks synchronizing GPS satellites, all depended on quantum behavior, on electrons and photons following rules that defied classical intuition. But beneath the applications, the interpretational questions remained, unresolved, occasionally surfacing in new forms. Hugh Everett, a graduate student at Princeton in the 1950s, proposed the most radical interpretation yet. What if the wave function never collapsed? What if every quantum measurement caused the universe to split, branching into parallel realities, one for each possible outcome? In one branch, the electron was measured here. In another branch there, both equally real, both continuing forward, a vast tree of bifurcating worlds growing with every quantum event. The many worlds interpretation, as it came to be called, was elegant mathematically. It took the Schrödinger equation completely seriously. No special role for measurement, no mysterious collapse, just unitary evolution, wave functions growing and branching. But the price was an infinity of universes, most of them forever inaccessible. And most physicists found the ontological extravagance too high a cost. Still, the idea persisted, gained adherents, especially as quantum computers began to be conceived, devices that could exploit superposition, holding qubits in combinations of 0 and 1 simultaneously, performing calculations on all possible inputs at once, in parallel, as if borrowing computational power from those other branches. David Bohm offered an alternative in the 1950s, a deterministic interpretation with hidden variables. Particles had definite positions always, guided by a quantum potential derived from the wave function, pilot wave theory. It reproduced all the predictions of standard quantum mechanics, but added an underlying reality, hidden from measurement but nonetheless present. Most physicists ignored Bohm's interpretation. It seemed baroque, adding elements that made no difference to experimental outcomes, violating Occam's razor. But it proved that deterministic alternatives to the Copenhagen interpretation were at least mathematically possible, even if they required faster-than-light influences to work. The real breakthrough in understanding came from an unexpected direction, from John Bell, a physicist at CERN, who in 1964 derived an inequality, a mathematical relationship that any theory based on local hidden variables would have to satisfy. Bell showed that Einstein's intuition, his belief that particles had definite properties before measurement and that no influence traveled faster than light, led to testable predictions, and those predictions differed from quantum mechanics for the first time. The interpretational debate could be settled by experiment rather than philosophy. It took decades for technology to advance sufficiently for experimenters to create pairs of entangled photons and measure their properties with enough precision. But in the 1980s, Alain Aspect and his colleagues in France performed the definitive tests, and quantum mechanics was vindicated. Bell's inequality was violated exactly as quantum theory predicted. Local hidden variables were ruled out. Either quantum mechanics involved faster-than-light influences, or particles truly didn't have definite properties before measurement, or reality was non-local in ways that defied classical imagination. The universe was genuinely stranger than Einstein had been willing to accept. The experiments on entanglement opened new vistas. If particles could be correlated across arbitrary distances, their quantum states linked in ways that defied spatial separation, perhaps this could be used not for communication. The laws of physics prevented sending messages via entanglement, but for other purposes: cryptography, computation, teleportation of quantum states. Quantum information theory emerged in the 1980s and 90s, treating quantum states as resources, asking what could be done with superposition and entanglement that classical physics couldn't achieve. Charles Bennett and Gilles Brassard showed that quantum mechanics enabled perfectly secure communication. Any eavesdropper would inevitably disturb the quantum states being transmitted, revealing their presence. Peter Shor discovered in 1994 that a quantum computer could factor large numbers exponentially faster than any classical algorithm, threatening the cryptographic systems that secured Internet commerce. Suddenly, quantum computing shifted from curiosity to urgent research priority. Governments and corporations poured resources into building devices that could maintain quantum coherence, preserving superposition long enough to perform useful calculations. The technical challenges were immense. Quantum states were fragile. The slightest interaction with the environment caused decoherence, superpositions collapsing into mixtures, quantum information leaking away as heat and noise. Maintaining a qubit required isolating it nearly perfectly, cooling it to millikelvin temperatures, shielding it from stray electromagnetic fields and vibrations. Yet progress came. First a handful of qubits, then dozens, ion traps holding charged atoms suspended in electromagnetic fields, superconducting circuits etched onto silicon chips, cooled until electrical resistance vanished and currents flowed without dissipation. Topological qubits exploiting exotic quantum states that were inherently protected from certain types of errors. I imagine the laboratories where this work proceeded. Dilution refrigerators maintaining temperatures colder than interstellar space, laser systems stabilized to fractional hertz, control electronics generating microwave pulses timed to picosecond precision, all to manipulate individual quantum systems, to choreograph their evolution, to read out their states without destroying the very information being sought. Quantum mechanics had come full circle from a theory that emerged reluctantly from puzzles about light and heat, through decades of philosophical controversy and stunning application, to a framework for entirely new technologies, devices that exploited the strangeness rather than fighting against it. That made superposition and entanglement into features rather than bugs. The condensed matter physicists, meanwhile, had been finding their own quantum wonders, superfluids that flowed without friction, superconductors that carried current without resistance, Both phenomena requiring quantum coherence at macroscopic scales, millions of atoms acting in concert, their wave functions overlapping, becoming one giant quantum state. The fractional quantum Hall effect, discovered in 1982, revealed even stranger behavior. Electrons in strong magnetic fields organizing into states with fractional charge, quasi-particles emerging from collective behavior. Any ones with statistics neither bosonic nor fermionic, a bestiary of exotic quantum phases, topological states of matter that couldn't be characterized by symmetry breaking alone. Bose-Einstein condensates were finally created in 1995. Eric Cornell and Carl Wieman cooling rubidium atoms to billionths of a degree above absolute zero, watching them suddenly coalesce into a single quantum state, a droplet of a matter where all the atoms shared the same wave function, moving as one, exhibiting interference effects visible to the naked eye. These macroscopic quantum phenomena blurred the boundary between the quantum and classical worlds, showing that the strangeness wasn't confined to atoms and photons, that under the right condition, matter itself could enter quantum states, behaving coherently across distances large enough to see. The 21st century brought quantum mechanics into an era of precision and control. Individual atoms could be trapped and manipulated, photographed, made to interact in choreographed sequences, what had been statistical ensembles. Billions of particles behaving on average according to quantum rules became individual systems, each one a laboratory for testing the foundations of quantum theory. Quantum simulators emerged, systems of trapped ions or atoms in optical lattices, arranged to mimic other quantum systems too complex to calculate. You couldn't solve the Schrödinger equation for 100 interacting particles. The computational resources didn't exist, but you could build a physical system with the same Hamiltonian, the same energy structure, and watch it evolve, using one quantum system to understand another. High-energy physicists pushed quantum field theory to extraordinary precision, the Standard Model, describing all known particles and 3 of the 4 fundamental forces, made predictions accurate to 10 decimal places, the anomalous magnetic moment of the electron, the mass of the W boson, quantities measured and calculated with precision that seemed almost obscene. Nature and mathematics agreeing to 1 part in 10 billion. The Higgs boson was finally discovered in 2012 at CERN, the Large Hadron Collider smashing protons together at energies high enough to briefly create the particle, or rather the quantum field excitation, that gave other particles their mass. The last missing piece of the Standard Model, predicted in 1964, found 48 years later. Quantum field theory vindicated yet again. Yet even in triumph, puzzles remained: quantum mechanics and general relativity. The 2 pillars of 20th century physics refused to merge cleanly at the Planck scale, where quantum fluctuations of space-time itself should become important. The mathematics broke down. Infinities appeared that couldn't be removed. Space-time foam, quantum gravity, string theory, loop quantum gravity. Various approaches attempted to reconcile the theories, but no experimental evidence yet distinguished between them. Black holes became theaters for exploring the tension. Stephen Hawking showed in 1974 that quantum mechanics predicted black holes should radiate, slowly evaporating, and this raised paradoxes. information falling into a black hole seemed to be destroyed, violating quantum mechanical unitarity, the principle that information is preserved. The black hole information paradox remained unresolved, with proposals ranging from firewalls at the event horizon to holographic principles where all the information was encoded on the surface. Cosmology, too, became quantum. The very early universe, fractions of a second after the Big Bang, existed in quantum states, superpositions of different geometries. And inflation theory suggested that quantum fluctuations, tiny variations in energy density, were stretched to cosmic scales, becoming the seeds of galaxies, the large-scale structure of the universe, everything we see, emerging from quantum uncertainty in the first moments of time. The cosmic microwave background radiation, mapped with increasing precision by satellites, showed patterns consistent with quantum fluctuations amplified by inflation. The universe itself bore the fingerprints of quantum mechanics, written across billions of light years in the faint temperature variations of primordial light. Meanwhile, quantum technologies matured from laboratory curiosities into commercial realities. Quantum key distribution systems secured communications for governments and financial institutions. Quantum sensors measured gravitational fields and magnetic fields with unprecedented sensitivity, enabling new forms of medical imaging, mineral prospecting, even the detection of hidden structures underground. Quantum computers reached 50, then 100 qubits, enough to perform specific calculations beyond the reach of classical supercomputers. Quantum supremacy, or quantum advantage, the milestone where quantum devices definitively outperformed their classical counterparts, was achieved and contested and achieved again, the definition shifting as classical algorithms improved and quantum devices grew more sophisticated. Google announced quantum supremacy in 2019. IBM disputed the claim, arguing their classical supercomputers could match the result, but the trajectory was clear. Quantum computers were improving exponentially. Error correction schemes were being implemented, and applications beyond cryptography breaking were emerging. Quantum chemistry simulations, optimization problems, machine learning algorithms that could exploit quantum parallelism. The interpretation question, the meaning of quantum mechanics, never entirely disappeared. It periodically resurged, taking new forms as experimental capabilities expanded. Weak measurement theory allowed glimpses of quantum systems without fully collapsing their states, giving paradoxical results that different interpretations explained differently. The delayed choice quantum eraser, experiments where future measurements seemed to retroactively determine the past behavior of particles, challenged naive notions of causality, forcing careful distinction between correlation and causation, between what happened and what could be known. Quantum Darwinism emerged as a framework, explaining how the classical world emerged from quantum substrate through interaction with the environment. Certain states, pointer states, were robust against decoherence, preferentially surviving while superpositions fragmented. This explained why we saw definite outcomes, why cats were alive or dead, but never both. The environment constantly measuring, selecting, amplifying certain quantum states into classical reality. Relational quantum mechanics proposed that quantum states were always relative to an observer, that there was no absolute wave function, only descriptions from within the universe, no view from nowhere, Every measurement was a physical interaction, creating correlations, and different observers could give different but equally valid descriptions of the same quantum system. I think of how the interpretations multiplied. Copenhagen, many worlds, Bohm, cubism, treating quantum states as subjective degrees of belief, consistent histories, spontaneous collapse theories, adding stochastic elements to the Schrödinger equation, each interpretation empirically equivalent, making the same predictions, yet carving reality at different joints, suggesting different ontologies. Perhaps this plurality was itself meaningful. Perhaps quantum mechanics was telling us that reality didn't conform to our classical categories, that insisting on a single interpretation missed the point, that complementarity extended beyond wave-particle duality to interpretational pluralism, different frameworks useful in different contexts, none capturing the full truth. The philosophical implications rippled outward into questions of consciousness, some arguing that the measurement problem required conscious observers, others that quantum mechanics in the brain might explain free will or qualia, most physicists skeptical, finding no evidence that consciousness played any special role in quantum mechanics, but the speculation persisted, fed by the genuine mystery of how subjective experience related to physical processes. Quantum biology emerged as a field, asking whether quantum coherence played functional roles in living systems. Photosynthesis seemed to involve quantum superposition, excitons exploring multiple pathways simultaneously, finding the most efficient route to the reaction center. Bird navigation might use entangled electron pairs in retinal proteins, sensitive to Earth's magnetic field. Though the evidence remained contested, the boundaries of quantum mechanics were being explored. How large could superpositions become before decoherence destroyed them? Molecules containing thousands of atoms had been put into superposition. Matter wave interferometry with biological molecules, viruses. The quantum classical boundary seemed to be a matter of degree rather than kind. No sharp dividing line, just increasing fragility as systems grew larger and more complex. Macroscopic quantum tunneling was observed in superconducting circuits, billion-atom systems tunneling through energy barriers, switching between states in ways that seemed to violate classical mechanics, the strangeness scaling up, refusing to be confined to the microscopic realm. Gravity itself became a target for quantum experiments, measuring the gravitational field of small masses, asking whether gravity could create entanglement between particles, whether space-time curvature was compatible with quantum superposition. Proposed experiments to put mirrors in superposition and detect gravitational effects, pushing towards a regime where quantum mechanics and general relativity would both be necessary, testing whether they could coexist. The century that began with Planck's reluctant quantum hypothesis had produced a complete revolution. Quantum mechanics was now the foundation of chemistry, materials, science, electronics, computation, cryptography, metrology, fundamental physics, its predictions tested to extraordinary precision across dozens of orders of magnitude in energy and distance. Yet it remained, in some sense, inscrutable. The mathematics was clear, but the meaning, what it said about the nature of reality, remained contested. 100 years of debate had refined the questions without fully answering them. I imagine standing at this point in the narrative, looking back across decades of discovery, forward towards applications not yet conceived. Quantum mechanics simultaneously the most successful and most mysterious theory in physics, precise beyond belief, strange beyond comprehension. The laboratory notebooks have become digital files. The equipment has grown from brass and glass to cryogenics and lasers. But the essential wonder remains that nature at its foundations refuses to be what we expected, refuses to conform to intuition built from everyday experience, and yet allows itself to be described, predicted, manipulated through mathematics of austere beauty. The quantum world is no longer inaccessible, hidden behind energy barriers and experimental limitations. It has become tangible, manipulable, a resource to be engineered, and yet its strangeness has not diminished. If anything, closer examination reveals new puzzles, new questions, new ways in which reality exceeds our categories. The deepening begins here, not with new facts, but with the resonance of what has been discovered. The way quantum mechanics has reshaped not just physics, but human understanding of what it means for something to exist. There is something profound in the uncertainty principle. Beyond its mathematical formulation, it suggests that nature at its foundations is not a collection of things with definite properties, but rather a web of potentialities, actualized only in relation to measurement, to interaction, to context. The electron orbiting an atom doesn't follow a path. It exists as a cloud of probability, a standing wave wrapped around the nucleus, and only when we look, when we measure, does it appear at a location, as if our looking calls it into being, though this anthropomorphizes what is really just interaction, entanglement between measuring device and measured system. This idea of relationality runs deep through quantum mechanics. Particles don't have intrinsic properties waiting to be discovered. They have dispositions, tendencies, correlations with other systems, and these correlations are fundamental, more basic than the individual elements being correlated. Entanglement demonstrates this most clearly. Two particles that have interacted can remain connected, their quantum states linked, such that measuring one instantaneously affects what can be said about the other, regardless of the distance separating them, not because information travels between them, but because they form a unified system, a single quantum state that cannot be decomposed into independent parts. Einstein called this spooky action at a distance, and it troubled him deeply, but experiments have confirmed it beyond doubt. The correlations are real. They violate Bell's inequalities. They exceed what any local hidden variable theory could produce. The quantum world is fundamentally non-local, holistic, resistant to reductionist decomposition. This non-locality doesn't allow faster-than-light communication. The randomness of quantum measurement outcomes ensures that, but it suggests something radical about the nature of space itself. Perhaps distance is not as fundamental as we imagine. Perhaps at the quantum level, spatially separated systems can remain intimately connected, woven together in ways that classical physics never anticipated. The wave of function collapse, that moment when quantum superposition gives way to definite outcomes, remains mysterious even after a century. Different interpretations offer different accounts, but all must grapple with the transition from many possibilities to one actuality, from potentiality to reality. In many worlds, there is no collapse, just branching. All outcomes occur, consciousness splitting along with the universe. experiencing one branch while other versions experience the others. It's a view both extravagant and austere, extravagant in its ontology, austere in its mathematics, taking the Schrödinger equation completely seriously with no additional postulates. In Copenhagen, collapse is fundamental but mysterious. Measurement is primitive, not further analyzable. This seems unsatisfying, leaving the quantum classical boundary undefined, but it has the virtue of matching how physicists actually work, calculating probabilities, making measurements, updating their knowledge based on outcomes. In quantum Darwinism and decoherence theory, collapse emerges from interaction with environment. Superpositions don't disappear. They become entangled with countless environmental degrees of freedom, scattered into inaccessibility. What looks like collapse from within is actually the growth of correlation, information spreading outward, becoming classical through redundancy. Each interpretation carves reality differently, yet all agree on predictions, on what observers will experience. This empirical equivalence might itself be telling us something, that our questions about what quantum mechanics really means presuppose classical metaphysics. Categories that don't apply. Asking which interpretation is true might be like asking whether light is really waves or really particles. The question assumes nature must conform to our categories, when perhaps it doesn't. The mathematics of quantum mechanics has its own kind of beauty. Hilbert spaces, unitary transformations, eigenvalues and eigenvectors. It's the geometry of possibility. And there's something profound in how physical laws can be expressed in this abstract mathematical language, how the structure of quantum theory seems almost inevitable once you accept certain basic principles, linearity, unitarity, the Born rule for probabilities. Symmetry plays a central role. Quantum mechanics respects certain symmetries, rotational invariance, time translation, and each symmetry corresponds to a conservation law, angular momentum, energy. This deep connection between symmetry and conservation, discovered by Emmy Noether, extends from classical to quantum physics, suggesting that symmetry is somehow fundamental to the structure of physical law. The gauge theories that describe fundamental forces, electromagnetism, weak nuclear force, strong nuclear force, are all quantum theories built on symmetry principles, local gauge invariance, the requirement that physics be unchanged by certain transformations, leads inevitably to the existence of force-carrying particles, photons, W and Z bosons, gluons, symmetry, generating reality. There's a kind of Platonic quality to this, the sense that mathematical structure determines physical reality, that the universe is comprehensible because it embodies mathematical relationships. Quantum mechanics pushes this further than classical physics ever did, replacing visualizable mechanisms with abstract operators and state vectors. And yet this abstraction is not emptiness. It describes nature with uncanny precision, the measurement problem, the interpretation questions, the philosophical puzzles. None of these diminish the practical success of quantum mechanics. Engineers designing quantum computers don't need to resolve whether many worlds is true. Chemists calculating molecular structures don't worry about collapse. The theory works, and that pragmatic success has driven a century of technological transformation. Yet the questions persist, because human beings want more than prediction. We want understanding. We want to know what the universe is like, not just how it behaves. and quantum mechanics frustrates this desire, offering mathematical certainty while withholding ontological clarity. Perhaps that frustration is itself a lesson, teaching us that reality at its foundations is not picturable, not reducible to mechanical models, that the universe is genuinely stranger than our evolved intuitions can grasp, and that mathematics, abstraction, is our best guide through territories where visualization fails. The quantum realm is not separate from the everyday world. It is the everyday world seen more clearly. Electrons in atoms obey quantum mechanics, and atoms compose everything we touch: the solidity of matter, the colors of objects, the flow of electricity, all quantum phenomena. We live immersed in quantum mechanics, our very existence dependent on exclusion principle, on tunneling, on the quantum rules governing chemical bonds. Consciousness itself, whatever it is, emerges from quantum mechanical processes in neurons, from ion channels and neurotransmitters and electrical signals, all obeying Schrödinger's equation, though the connection between those physical processes and subjective experience remains mysterious. The hard problem of consciousness intersecting with the measurement problem in ways no one has resolved. The story of quantum mechanics is unfinished. Experiments continue. Quantum gravity remains elusive. The interpretation debate goes on. New applications emerge. But something fundamental has been learned, something about the limits of human intuition, the power of mathematics, the strangeness of nature. We began in darkness, in the comfortable certainty of classical physics, and quantum mechanics led us into a stranger land, where particles are waves, where observation affects reality, where distant systems remain entangled, where uncertainty is fundamental. And yet, in that strangeness, we found precision, beauty, the foundations of modern technology, and perhaps a deeper truth about existence itself. The laboratories are quieting now, the experiments winding down, the calculations saved and filed away, but the quantum world continues, superpositions evolving, wave functions spreading, entanglement growing, all according to equations discovered by human minds, seeking to understand. In the stillness, I can almost hear it, the hum of the universe at its smallest scales, neither wave nor particle, but something else, something mathematics can describe, but words can barely capture, reality refusing our categories, insisting on its own strange terms. The textbooks will be written and rewritten, the courses taught, students puzzling over the double-slit experiment, the uncertainty principle, trying to reconcile what they're told with what they feel must be true, and gradually, perhaps, accepting that nature is under no obligation to match our intuitions. Quantum mechanics stands as both achievement and mystery, triumph and puzzle, the most successful physical theory ever devised, and the most philosophically perplexing. It has given us precision and wonder in equal measure, and after a century, its strangeness has not diminished. If anything, deeper investigation reveals new layers of peculiarity, new ways in which reality exceeds expectation. The night deepens, and the quantum world persists, unchanged by our understanding or lack thereof. Electrons orbiting, photons propagating, wave functions evolving, all the strange machinery of existence, continuing its dance, indifferent to observation, yet somehow miraculously comprehensible, describable, predictable, through symbols on a page, through mathematics, through human thought, reaching toward the foundations of what is. And perhaps that is the deepest mystery. Not that quantum mechanics is strange, but that it can be known at all, that minds built from quantum particles, evolved to navigate a classical world, can nonetheless grasp the principles governing their own existence, can write equations that predict the behavior of electrons and photons, can build technologies exploiting quantum effects, can peer into the heart of matter and find not chaos, but law, not confusion, but structure, beautiful, terrible, strange, and somehow against all odds, intelligible. The words are fading now, dissolving like wave functions in an environment, spreading, entangling, becoming part of the larger system. And in that dissolution, there is something appropriate, something quantum, the boundaries between ideas becoming uncertain, the narrative itself entering superposition, neither quite finished nor continuing, both and neither, suspended in the space between, and the silence returns, deeper than before, carrying within it all that has been said, and all that remains unspeakable, the quantum world, vast and intimate, distant and immediate, forever strange, forever here, the ground beneath everything, including these words, including this moment, including the consciousness reading them, all of it quantum, all of it mystery, all of it precisely described and utterly inexplicable. And in that paradox, perhaps the deepest truth that we can know without fully understanding, that mathematics reaches where intuition fails, that the universe reveals itself in equations, even as it refuses to be visualized, to be grasped, to be anything other than what it impossibly is. I stand at the edge of an idea, and the idea is vast, stretching backward through millennia, through dust and memory, through layers of earth that hold the whispers of something ancient, something foundational. There is a place that exists now only in fragments, in clay tablets pressed with wedge-shaped marks, in the geometric patterns of sun-dried brick, in the ghost lines of canals that once carried water through an impossible garden. And tonight, I find myself drawn there, not as a visitor, but as a witness to the slow accumulation of human thought, human ambition, human need. The land between two rivers, that is what the name means. Mesopotamia, from the Greek words for middle and river, though the people who lived there first would not have called it that. They would have known it simply as the world, as the black-headed people, as Sumer, as Akkad, as Babylonia, as the place where the Tigris and Euphrates descend from distant mountains and spread their gift of silt across an otherwise unyielding plain. I imagine standing there in that river valley, 5,000 years removed from electric light, from the hum of engines, from any sound except wind and water and the occasional bleating of sheep in the distance. And I see how the landscape itself is both generous and demanding, how it floods with seasonal precision, depositing rich, dark earth, then recedes, leaving behind the challenge of survival in a place where rain is scarce and summer heat is merciless. The rivers move slowly, their surfaces catching the bronze light of late afternoon, reflecting palm trees that cluster along the banks like patient guardians. And beyond the green ribbon of vegetation, the land extends in shades of ochre and pale gold, flat, seemingly endless, holding secrets in its silence. This is where it began, not all of it, But so much of what we consider the architecture of civilization, the framework upon which cities and laws and literature would be built, and the beginning was not sudden, not a single moment of revelation, but rather a gradual accumulation, like sediment settling, layer upon layer, generation upon generation. I think about the first settlements, small clusters of reed houses near the water's edge, people who had learned to plant barley and emmer wheat in the rich soil left by the floods, who had domesticated sheep and goats and cattle, who were beginning to understand that staying in one place, building something permanent, might be possible, might be preferable to the endless movement of the nomadic life. The sun moves across the sky, and with it, the shadows lengthen over mud brick walls that rise higher each generation, over temples that begin as simple shrines and grow into massive stepped pyramids called ziggurats, over marketplaces where goods from distant mountains and far coasts change hands, copper and lapis lazuli and timber and stone. There is something hypnotic about imagining the rhythm of life in these early cities, the way the day would begin before dawn with the lighting of fires, the preparation of bread, the opening of workshops where craftsmen shaped clay and hammered metal and wove textiles, the way the streets would fill with voices speaking Sumerian, later Akkadian, languages that sound in my mind like water over stones, unfamiliar, musical, carrying the weight of human need and human wonder. I see the scribes seated in the shade of a courtyard, reed styluses in hand, pressing wedge shapes into soft clay tablets, recording grain deliveries, temple offerings, the terms of a marriage contract, the boundaries of a field, and in doing so, creating something unprecedented, a memory outside the human body, a way to speak across time. The cuneiform signs emerge from the clay like constellations, each one a small constellation of marks, triangular impressions that represent not just objects, but sounds, syllables, the building blocks of language made visible, made permanent. And with this technology, this profound invention, the interior life of ancient Mesopotamia begins to reveal itself, not just in administrative records, but in poetry, in prayers, in letters between fathers and sons, in the epic tale of a king who sought immortality and found instead the value of a well-built wall. Night falls over the river valley, and the darkness is complete, except for oil lamps flickering in windows, torches carried by night watchmen, the distant glow of a temple where priests maintain the eternal flame, and above it all, stars so bright and numerous they seem almost close enough to touch, the same stars that Mesopotamian astronomers observed and catalogued with astonishing precision, tracking the movements of planets, predicting eclipses, mapping the heavens with the same meticulous attention they brought to mapping the earth. This is where I begin, in the presence of that ancient darkness, that ancient light, listening for the echoes of voices that spoke of gods and kings, of floods and harvests, of justice and revenge, of love and death, voices that shaped the first written words, the first cities, the first codes of law, voices that still resonate, faint but unmistakable across the enormous distance of time. The story begins much earlier than the cities, begins in a time when the southern plains of Mesopotamia were still marshland and estuary, when the Persian Gulf extended much farther north than it does today, and the people who would eventually become the Sumerians were perhaps still migrating, still searching for a place to settle. their origins obscured by the very success of what they would build. We do not know where they came from, these people who called themselves the black-headed ones, their language unrelated to any other known tongue, standing alone like an island in a sea of Semitic speech. And this linguistic isolation is one of the great mysteries, a question that remains suspended in the space between evidence and imagination. But what we do know is that by around 5,000 years ago, perhaps a few centuries earlier, they were there in the southernmost reaches of the river valley, building something unprecedented. The first settlements were humble, built of bundled reeds plastered with mud, structures that echoed the materials at hand, the papyrus-like reeds that grew in dense thickets along the waterways, and even later, when they learned to make bricks from the river mud. They continued to build with those bundles of reeds incorporated into the design, remembered in the ribbed columns of later temples, architectural memory of origins. Eridu, that is the name that appears in the king lists as the first city, the place where kingship descended from heaven, and archaeological evidence confirms human habitation there going back, perhaps 7,000 years, layer upon layer of rebuilding. Temples constructed atop the ruins of earlier temples, each generation raising the sacred platform a little higher, creating over millennia the artificial mountain that would become the signature form of Mesopotamian worship. I imagine the early farmers working the fields in the cooler hours of morning and evening, understanding already that water was everything, that the rivers gave life but also took it away, that floods could destroy as easily as they nourished. And so they began to dig, simple channels at first, directing water where it was needed, keeping it away from where it would do harm. And these first tentative attempts at irrigation would evolve into something extraordinary, a network of canals and dikes and reservoirs that transformed the landscape, that made civilization possible. By the fourth millennium before the Common Era, settlements were growing into towns, and towns into cities. Uruk rising from the plain like a declaration, its population swelling to perhaps 50,000 people, an almost incomprehensible concentration of humanity for that time, surrounded by 6 miles of defensive walls, dotted with temples whose facades were decorated with colored clay cones, pressed into the mud brick to create geometric patterns, red and white and black, glittering in the harsh sunlight. The temple complexes dominated these early cities, vast estates dedicated to the gods, and it was here that the innovations emerged, the need to track offerings, to record the distribution of grain and oil and wool to temple workers, to manage the increasingly complex economy of a settled agricultural society. And this need gave birth to the first writing. The earliest tablets are simple, pictographic. A circle with a cross means sheep. A bowl shape means food or bread. Symbols that represent the objects themselves. But already there is something revolutionary happening, the human mind externalizing its memory, creating a technology that will outlast flesh and bone, that will speak across the silent gulf of death. I see the first scribes, perhaps temple administrators, realizing that these marks could represent not just things but sounds, that the symbol for water could also mean the sound A in the Sumerian language. And with this insight, this leap of abstraction, writing became capable of recording anything, not just inventories, but also stories, prayers, laws, the full complexity of human thought. The cities multiplied, Ur and Lagash and Nippur, Kish and Umma and Larsa, each with its own patron deity, its own agricultural hinterland, its own ambitions, and between them the relationship was sometimes cooperative, sometimes violently competitive. Wars fought over water rights, over boundary stones, over the favor of the gods, and from these conflicts, from the need to organize labor for irrigation projects and defense, came the institution of kingship. The earliest kings were perhaps war leaders, men who proved themselves in battle and then retained authority in peacetime, or they were temple administrators who accumulated enough power to rule in both sacred and secular spheres. And the line between these roles was never clear. The king was always, in some sense, the representative of the gods, the intermediary between heaven and earth, responsible for maintaining Mahat, the cosmic order, ensuring that the rituals were performed correctly, that justice was administered, that the walls were strong. The king lists speak of dynasties lasting thousands of years, of rulers who reigned for impossible spans, 36,000 years, 28,800 years, and then, after a great flood, the lengths become more reasonable, more human, and scholars debate whether these early fantastic numbers represent real chronology, compressed and mythologized, or whether they are purely symbolic, expressions of the feeling that time itself was different once, deeper, more sacred. The flood appears again and again in Mesopotamian literature, a catastrophe that divided history, that washed away an earlier world, and whether it refers to a specific historical event, perhaps a devastating inundation around 5,000 years ago, or whether it represents the accumulated memory of countless floods, the existential threat of living between two powerful rivers, the story itself became foundational. The righteous man warned by his God, building a boat, saving the animals, surviving the deluge that was meant to destroy humanity for its noise, its chaos, its failure to properly revere the divine. By the early third millennium, the cities had developed distinct identities. Uruk was a center of craft production and trade, its workshops producing pottery and textiles that spread throughout the region. Ur became wealthy from commerce, its position near the coast, giving it access to goods from the Persian Gulf and beyond. Lapis lazuli from Afghanistan, carnelian from India, copper from Oman, and Nippur held religious authority, its temple to Enlil, the chief god, making it a pilgrimage site, a neutral ground where kings from rival cities could meet and negotiate. The irrigation systems grew more sophisticated, more extensive, main canals feeding into smaller channels, water distributed according to complex schedules and regulations. And this required coordination, required authority, required a bureaucracy capable of managing the flow of water and the disputes that inevitably arose when one city's use affected another's supply. And so the practical necessities of survival in an arid land shaped the political structures, created the need for law, for record keeping, for the apparatus of state. I imagine walking through Uruk in its glory, through streets that follow no grid, winding organically between tightly packed houses, walls rising directly from the narrow alleys, the ground floor windowless for security and coolness, the upper stories sometimes projecting over the street, creating patches of shade, and the houses themselves built around central courtyards, open to the sky, where families cooked and worked and slept under the stars in summer. The sounds would be the sounds of craft, of commerce, the rhythmic pounding of copper being hammered into shape, the clack of the vertical loom as a weaver works, voices haggling over the price of dates or barley, children playing games with knuckle bones, and underlying it all, the murmur of water flowing through the city's canals, the lifeline that makes all of this possible. In the temples, priests performed the daily rituals, clothing the statue of the god, offering food and drink, burning incense, maintaining the relationship between the human and divine realms that ensured fertility, prosperity, victory. And these weren't merely symbolic acts. They were understood as essential maintenance, as necessary as repairing a breach in a canal wall. The cosmos required constant attention, constant propitiation, or it would fall back into chaos. The gods themselves were numerous, each city's patron deity, supreme in their own territory but acknowledged as part of a larger pantheon. And the sky god, Enlil the lord of wind and storm, Enki the god of fresh water and wisdom, Inanna the goddess of love and war. Complex personalities prone to jealousy and anger and occasional mercy, divine beings who mirrored human society, who had families and rivalries and councils, who could be influenced by offerings and prayers, or who might simply act according to their own inscrutable will. And alongside the worship, alongside the daily labor of farming and craft, there was already art, already literature, the cylinder seals carved with intricate scenes, banquets and battles and processions, pressed into wet clay to mark ownership or authority, and poetry, hymns to the gods composed with sophisticated literary techniques, parallelism and repetition and allusion, verses that were performed, chanted in temple ceremonies, preserved on tablets for other scribes to copy and study. This was the foundation, the early phase when the fundamental patterns were established, when humanity was learning to live in unprecedented density, creating the institutions and technologies and cultural forms that would define not just Mesopotamia but all subsequent civilizations, the city, the state, the written word, the law code, the epic poem, all emerging from the silt between two rivers, from the ingenuity born of necessity, from the slow accumulation of knowledge passed from generation to generation, each one building on what came before, raising the platform a little higher, creating something that would endure long after the rivers changed course and the cities fell silent. The transition from the early dynastic period into what scholars call the Akkadian Empire marks a profound shift, not just in political organization, but in the very conception of what power could mean, what territory could encompass. And this transformation centers on a single figure whose historicity is debated, but whose impact is undeniable. Sargon of Akkad, a name that means true king and may itself be a title rather than a birth name, a man who rose from obscurity to create something unprecedented. The legends say he was born in secret, placed in a reed basket and set adrift on the river, discovered and raised by a gardener, later becoming cupbearer to the king of Kish. And whether these details are historical or borrowed from mythic archetypes, they speak to the revolutionary nature of his rise, a commoner who seized power, who unified the squabbling city-states under a single authority, who extended his control from the Persian Gulf to the Mediterranean, creating the first true empire in human history. Around 4,300 years ago, give or take a century, Sargon established his capital at Akkad, a city whose exact location remains unknown despite centuries of searching, buried somewhere beneath the alluvial plain, its name surviving in the language that became the lingua franca of Mesopotamia for the next 2 millennia, Akkadian, a Semitic tongue that coexisted with Sumerian, gradually replacing it in daily speech, while Sumerian persisted as the language of scholarship and ritual. Like Latin in medieval Europe, the empire Sargon built required new technologies of administration, new ways of projecting power across distance, and so the apparatus of state grew more sophisticated. Royal inscriptions carved in stone proclaimed his victories, his justice, his divine mandate, and these inscriptions were written in both Sumerian and Akkadian, a political statement as much as a practical one, honoring the old while asserting the new. I imagine the armies marching, soldiers equipped with bows and spears and axes, organized into units, supplied by a logistics system that could move grain and water across hostile terrain, conquering cities that had never known foreign rule, installing governors loyal to Sargon, demanding tribute, and with conquest came trade, goods flowing along protected routes, merchants moving freely under the king's authority, wealth accumulating in Akkad and redistributed to maintain the military, the bureaucracy, the monumental building projects that proclaimed imperial glory. But empires are fragile, maintained by constant effort, and when Sargon died, his sons and grandsons struggled to hold what he had won. Rebellions flared in the Sumerian cities, resentful of Akkadian dominance, and it took ruthless suppression to maintain control. Entire cities destroyed as examples, populations deported, the inscription of Sargon's grandson Naram-Sin describing how he defeated a coalition of rebellious kings, how he claimed divinity for himself, wearing the horned crown previously reserved for gods, and having his image carved on victory steles showing him trampling enemies underfoot, ascending a mountain with the stars of the gods shining above. The Akkadian Empire lasted perhaps a century and a half, and its collapse was sudden, catastrophic, caused by a combination of internal rebellion and external invasion, raids by the Gutians from the Zagros Mountains, and possibly, though this remains debated, by climate change, a severe drought that may have driven pastoral peoples from the surrounding steppes into the fertile river valley, creating a cascade of migrations and conflicts that the imperial structure could not withstand. In the chaos that followed, power devolved back to the city-states, but the idea of empire had been planted, the memory of unified rule under a single king, and after a period of fragmentation, the Sumerian cities experienced a renaissance, particularly which emerged as the dominant power around 4,100 years ago, establishing what scholars call the third dynasty of or III, a period of extraordinary cultural achievement and bureaucratic complexity. The kings of III recreated many aspects of the Akkadian state, but with a Sumerian identity, a conscious revival of older traditions expressed in art and architecture and official language, the great ziggurat of rising in tiers of baked brick, its corners oriented to the cardinal directions, its massive form visible for miles across the flat plain. An artificial mountain connecting earth to heaven, the dwelling place of Nana, the moon god, and around it the temple complex with its workshops and storerooms and administrative offices, the economic heart of the state. The bureaucracy of Ur-3 was astonishingly detailed. We have tens of thousands of clay tablets recording the minutiae of temple and state administration, receipts for livestock, ration distributions, work assignments, each transaction documented by scribes who spent years learning the complex cuneiform system, mastering not just the signs, but the formulaic language of administration, the proper way to record a delivery of wool or an assignment of laborers to canal maintenance. I see the archive rooms, shelves stacked with tablets, some still soft and needing to be dried, others already baked hard by time or accident, each one a tiny fragment of the vast informational apparatus that kept the state functioning, that tracked resources from production to consumption, that made it possible to feed and clothe thousands of workers, to plan agricultural cycles, to prepare for festivals, to maintain the infrastructure of canals and walls and roads. The legal system, too, became more codified, building on earlier traditions, establishing principles that would echo through later law codes, the presumption that crimes could be atoned through compensation rather than vengeance, that contracts must be witnessed and recorded, that even the powerful could be held accountable to written standards, though of course the reality often fell short of the ideal. Justice available more readily to those with resources and connections. Women in this society occupied complex positions. Elite women could own property, conduct business, serve as priestesses, some even ruled as regents. But the general trend over time was toward increasing restrictions, increasing emphasis on patriarchal control, marriage contracts that treated women as property to be exchanged, divorce laws that heavily favored men, and yet within these constraints, individual women found ways to exercise agency, to accumulate wealth, to influence the powerful men in their lives. The scribal schools, called eduba or tablet houses, trained boys from elite families in the arts of writing and calculation, an education that could take years, beginning with copying simple signs, progressing to syllabaries and word lists, mathematical tables and legal formulae, and finally to literature, the great works of Sumerian poetry and wisdom, students copying the same texts generation after generation, preserving them, and in the process creating a literary canon, a shared cultural heritage that transcended individual cities. Among the texts they copied were hymns, prayers addressed to various gods, praising their attributes, requesting their favor, and myths, stories of creation and cosmic battle, the tale of Gilgamesh and Enkidu, of Inanna's descent to the underworld, narratives that explained the nature of reality, the relationship between gods and humans, the inevitability of death, and the importance of leaving a name, a reputation, something that would survive the body's dissolution. The astronomical observations continued and deepened, priests tracking the movements of Venus with extraordinary precision, recognizing patterns, understanding that celestial events could be predicted, compiled in omens lists that correlated heavenly phenomena with earthly outcomes. If Venus appears in such and such position, the king will die, the harvest will fail, the enemy will attack. And while we might dismiss this as superstition, it represented a sophisticated understanding that the universe operated according to regular patterns, that observation and record-keeping could reveal those patterns, a proto-scientific impulse, even if the causal framework was religious. Mathematics, too, flourished, the Mesopotamians using a sexagesimal system, base 60, which gave them great flexibility in calculation, allowing them to express fractions easily, to solve complex problems of land measurement and volume, and this mathematical tradition would survive, passing to the Greeks and eventually to us in the 60 minutes of an hour, the 60 seconds of a minute. The 360 degrees of a circle, inheritances from Mesopotamian scribes working by lamplight in temple offices 4,000 years ago. But the Ur-3 state, despite its sophistication, despite its elaborate systems of control and documentation, also collapsed, weakened by the same pressures that had destroyed Akkad, incursions by Amorite peoples from the west, internal rebellions, possibly environmental stress, and around 4,000 years ago, the last king of Ur was carried off into captivity, his city destroyed, and in the lamentations composed afterward, we hear genuine grief, a city personified as a woman weeping for her lost children, the temples abandoned, the gods departed, everything that seemed permanent revealed as fragile. Yet even in collapse there was continuity. The Amorites who conquered the Sumerian cities adopted Mesopotamian culture, learned cuneiform, worshipped the old gods alongside their own, established new dynasties in the old cities, and among these Babylon began its rise, a city that had been relatively minor, but whose location on the Euphrates, at the nexus of trade routes, Yasher gave it strategic importance, and under a series of capable rulers, it accumulated power, wealth, authority, preparing the ground for its greatest king. Hammurabi, ruling around 3,750 years ago, expanded Babylon's control methodically through diplomacy and warfare, conquering Muri and Larsa and Eshnunna, reunifying much of Mesopotamia under Babylonian authority, and while he was not the first to issue a law code, his is the most complete that survives, inscribed on a black stone stele, with the image of the king receiving authority from the sun, god Shamash. 282 laws covering everything from property rights to personal injury, from family relations to commercial transactions. The laws reveal a society stratified by class, different penalties for the same crime depending on whether the victim was a noble, a commoner, or a slave. The famous principle of an eye for an eye applying only within the same social tier, but they also show concern for the vulnerable, the widow and orphan, limits on the power of creditors, requirements that officials act justly or face severe penalties, an attempt, however imperfect, to create a predictable legal framework, to replace arbitrary power with written standards known to all. I imagine the stele standing in a public space, passers-by pausing to read, or more likely, to have read to them by a scribe, the laws that governed their lives, the protections they could claim, the obligations they must fulfill, and this publicness, this assertion that law should be visible and knowable, represents something profound, a check on tyranny, a foundation for social order based on more than force. Babylon under Hammurabi became a cultural center, its prestige attracting scholars and artists, its scribal schools preserving and creating literature, its temples serving as centers of learning, and the Babylonian dialect of Akkadian began to spread, becoming the language of diplomacy and scholarship throughout the Near East. Tablets from Egypt to Anatolia, written in Babylonian cuneiform, a testament to the soft power that accompanied military conquest. The city itself grew magnificent, though most of what we associate with Babylon, the Ishtar Gate, the Hanging Gardens, came much later. In Hammurabi's time, it was already substantial, surrounded by walls, divided by the Euphrates, temples rising above the mud brick houses, markets bustling with merchants from distant lands, workshops producing the finest textiles and metalwork, and at the center, the palace complex where the king administered justice. Received ambassadors, planned campaigns, maintained the delicate balance of power that held the empire together. The empire Hammurabi built did not long survive his death. Within a generation, Babylon's control over the south weakened, and new powers emerged in the shifting landscape of alliances and conquests, the Kassites descending from the Zagros Mountains to establish a dynasty that would rule Babylon for 4 centuries, the longest-lasting dynasty in Mesopotamian history, and in the north, the kingdom of Mitanni rose to prominence, followed by the resurgence of Assyria, a city-state that had existed in the shadow of greater powers but would eventually surpass them all. The Kassites were outsiders, like the Amorites before them, but they too became Babylonianized, adopting the language and religion and administrative practices of the land they conquered, maintaining the temples, supporting the scribal schools, adding their own gods to the pantheon while honoring the old ones, and under their rule, Babylon remained a center of learning, its libraries preserving the literary heritage, its astronomers refining their observations, its mathematicians solving increasingly complex problems. Trade networks expanded during this period, reaching unprecedented distances. Lapis lazuli from Afghanistan appearing in Egyptian tombs, amber from the Baltic found in Mesopotamian graves, tin from Central Asia, essential for bronze production, traveling along routes that connected civilizations from the Mediterranean to the Indus Valley. And with trade came cultural exchange, ideas moving along the same paths as goods, influencing art and architecture and religious thought in ways both obvious and subtle. But it was in the north, in Assyria, that the most dramatic developments unfolded. The Assyrian state had existed since the 3rd millennium, centered on the city of Ashur on the Tigris, named for its patron god, a trading hub that grew wealthy from commerce and gradually accumulated military power. And by the 14th century, before the Common Era, Assyria was challenging its neighbors, conquering territory, establishing the patterns of expansion and administration that would characterize its later empire. The Assyrians were warriors, their kings boasting in inscriptions of campaigns and conquests, of cities besieged and captured, of tribute extracted and rebels punished, and they developed military innovations that gave them decisive advantages, iron weapons when others still used bronze, cavalry alongside chariots, siege engines capable of breaching the strongest walls, and a logistical system that could supply armies in the field for extended campaigns, projecting power across vast distances. I imagine the Assyrian army on the march, columns of soldiers in bronze and leather armor, archers and spearmen, chariots raising dust, siege towers disassembled and carried on wagons, and behind them administrators and scribes, ready to organize the conquered territories, to assess tribute, to deport populations deemed unreliable, replacing them with people from other regions, a deliberate policy of mixing populations to prevent rebellion, to break local identities and create dependence on the central authority. The reliefs from Assyrian palaces show this military culture in vivid detail. Carved stone panels depicting battles and hunts, sieges with soldiers climbing ladders, enemies impaled or beheaded, royal lion hunts where the king demonstrates his courage and strength. And these weren't merely decorative, they were propaganda, assertions of power meant to impress visitors, to intimidate vassals, to glorify the king as the chosen of the gods, the bringer of order to a chaotic world. But Assyria was more than military might. Its capital cities, first Ashur, then Nimrud, then Khorsabad, finally Nineveh, became centers of culture and learning. Royal libraries collected tablets from throughout the empire, copies of ancient texts, contemporary scholarship, diplomatic correspondence. The great library of Ashur-banipal at Nineveh, containing perhaps 30,000 tablets, the largest collection in the ancient world, preserving works that would otherwise have been lost, including the most complete version of the Epic of Gilgamesh. Ashur-banipal himself, ruling in the 7th century before the Common Era, was unusual among Assyrian kings for his scholarly interests. He boasted of his ability to read ancient Sumerian and complex cuneiform, of his knowledge of mathematics and divination, and he actively collected texts, sending scribes throughout the empire to copy works for his library, creating a repository of knowledge that attempted to gather all the wisdom of Mesopotamia in one place. The empire reached its greatest extent under Ashur-banipal, stretching from Egypt to the Persian Gulf, from the Mediterranean to the Iranian plateau, and the administrative machinery required to govern such territory was extraordinarily complex. Provinces ruled by governors reporting to the king, a network of roads with stations for royal messengers, an intelligence system that kept the court informed of events in distant regions, and elaborate rituals and ceremonies that reinforced the king's authority. His role as the representative of Ashur, the god who commanded conquest, who demanded tribute and obedience. Yet even at its height, the empire contained the seeds of its collapse. The constant warfare exhausted resources. The deportations created resentment. The bureaucracy became unwieldy. And when external pressures mounted, when new enemies appeared, the structure proved brittle, unable to adapt. And in the final decades of the 7th century before the Common Era, everything fell apart with shocking speed. The Medes from the Iranian plateau allied with the Babylonians, who had chafed under Assyrian domination for generations, and together they destroyed the Assyrian heartland. Nimrud fell, then Ashur. Finally Nineveh in 612 before the Common Era. The great city burned so thoroughly that its ruins would lay hidden for millennia, and with its fall, the Assyrian Empire vanished, its military might, its administrative sophistication, its cultural achievements, all consumed in the conflagration of revenge. But from the ashes, Babylon rose again, greater than before, the Neo-Babylonian Empire under Nabopolassar, and his son Nebuchadnezzar expanding to control much of what Assyria had held. And Nebuchadnezzar transformed Babylon into the most magnificent city of the ancient world, the double walls so thick that chariots could race atop them, the Ishtar Gate covered in blue-glazed bricks with images of lions and dragons and bulls, the ziggurat of Marduk rising in 7 tiers, perhaps the inspiration for the Tower of Babel, and possibly, though evidence is uncertain, the Hanging Gardens, terraced and irrigated, a green wonder in the desert heat. The Babylonians of this era were conscious inheritors of a long tradition. They collected ancient texts, restored old temples, traced their legitimacy back through centuries of history, and they developed astronomy to new heights. Systematic observations over decades, mathematical models that could predict planetary positions and eclipses with remarkable accuracy. The beginnings of a true science on observation leading to hypothesis, leading to prediction, leading to refinement. I see the astronomers on the ziggurat, night after night, tracking stars across the sky, recording positions with patient precision, and in the temple libraries, scholars compiling this data, looking for patterns, creating tables, understanding that the cosmos operated according to mathematical principles, that the apparent chaos of heavenly movements concealed deep regularities. And this knowledge had practical applications: agricultural, timing, festival scheduling, and political. The ability to predict eclipses gave priests and kings powerful tools for maintaining authority. But the Neo-Babylonian Empire was brief, barely a century, before a new power emerged. The Persians under Cyrus sweeping west from Iran, and in 539 before the Common Era, Babylon opened its gates without a fight, Cyrus entering peacefully, proclaiming himself liberator rather than conqueror, and Mesopotamia became a province, a satrapy of a larger empire, governed from distant capitals. Its independence ended, though its culture remained influential. Under Persian rule, then Macedonian after Alexander's conquest, then Seleucid Greek, then Parthian, the cities of Mesopotamia gradually declined. The irrigation systems deteriorated without central maintenance. The canals silted up. Salt accumulated in the soil from millennia of irrigation, reducing fertility, and populations drifted away to new centers of power, to Damascus and Alexandria and Antioch, the old cities contracting, some abandoned entirely. Cuneiform, which had recorded human thought for 3,000 years, was gradually replaced, first by Aramaic, written in alphabetic script, easier to learn, more flexible, then by Greek, and the last datable cuneiform tablet comes from the 1st century of the Common Era, an astronomical text, the final whisper of a tradition that stretched back to the dawn of writing, and, with its passing, the ability to read the accumulated wisdom of millennia was lost, the tablets becoming incomprehensible artifacts, dead voices waiting in darkness for someone to decipher their speech. The Mesopotamian gods lingered longer, worshipped in some places into the early centuries of the Common Era. But Christianity and other new religions displaced them. The great temples fell into ruin, their bricks carried away for other building projects, their ziggurats eroding back into shapeless mounds, and the very names of cities became confused. Later travelers unable to identify which tell was Babylon, which was Nineveh, the landscape of tells, artificial hills marking ancient settlements, stretching across the plain like burial mounds of a vanished world. And yet the influence persisted, invisible but pervasive, in the 7-day week inherited through Jewish tradition from Babylonian astronomy, in the division of the circle, in the mathematical techniques that passed through Greek and Arab scholars to medieval Europe, in the legal principles, in the literary motifs, the flood story, the tragic hero seeking immortality, the beloved descending to the underworld, in the very idea of the city, the state, the empire, patterns, first established between two rivers. The agricultural techniques, the administrative methods, the astronomical knowledge, the mathematical insights, all moved outward, influencing peoples who never knew their origin, becoming part of the common heritage of civilization, foundations so deeply buried that we forget they exist. Until archaeologists dig through layers of earth and find the tablets, brittle and brown, covered in wedge-shaped impressions, and scholars spend lifetimes learning to read them, recovering voices that speak of flood and drought, of love and loss, of the daily transactions of life, of humanity in its earliest experiments with complexity, with permanence, with the attempt to create something that would outlast individual lives, that would touch eternity. And so I return to the silence, to the mounds rising from the plain like gentle waves frozen in earth, and I think about what it means that this beginning, this first great experiment in complexity, happened here, in a place that offered no easy answers, no forests full of timber, no mountains rich with metal, no reliable rainfall, only two rivers and the silt they carried and the challenge of making life possible in between. The innovation was born of necessity, irrigation because without it nothing would grow, writing because the systems became too complex to hold in memory, law because density created friction, conflict, the need for agreed-upon rules, and cities because collective effort could achieve what individuals could not, could move the earth, redirect the water, build monuments that scrape the sky. But there was more than necessity. There was also wonder, the impulse to look at the stars and see not chaos, but pattern, to ask where the world came from, why humans die, while gods do not, what makes a life worth living. And the answers they found, preserved in epic and hymn and wisdom literature, still resonate, still speak to questions we continue to ask. The Epic of Gilgamesh, that ancient poem, 2/3 God and 1/3 human, the king who has everything except the one thing he truly wants, immortality, friendship, meaning, and his journey takes him to the ends of the earth, through darkness, across deadly waters, to find the one man who survived the flood, who was granted eternal life. And the lesson he learns is not what he sought. He learns that death is inevitable, that the quest for immortality is futile, but that a well-built wall, a good name, acts of kindness and courage, these can outlast the body. There is something profoundly modern in this ancient wisdom, the acceptance of limitation, the focus on legacy rather than literal survival. And Gilgamesh returns to Uruk and shows his companion the walls he built, the city he made great, and finds in that a kind of peace, a resolution to the terror of mortality. Or consider the wisdom literature, the Akkadian dialogue between a master and his slave, where every proposed action is first endorsed, then contradicted. Should I go to the palace? Yes, master, for the king will honor you. No, master, for the king will destroy you. Should I love a woman? Yes, master, for love is sweet. No, master, for women are faithless. And on, until the slave suggests the only solution is death for both of them. And the master asks if the slave will die first, and the slave responds that no. The master cannot live even 3 days without him. A dark comedy about the impossibility of wisdom, The contradictory nature of existence, performed 4,000 years ago and still cutting, still true. The religious thought, too, shows remarkable sophistication. The gods are not omnibenevolent, not all-powerful. They have limitations, make mistakes, feel regret. They created humans to serve them, to grow food and maintain temples, to relieve the gods of labor, and this relationship is transactional. Sacrifices for blessings, prayers for protection, but it can fail. The gods can be capricious, unjust, and this generates a literature of complaint. The righteous sufferer, questioning why the gods allow the innocent to suffer while the wicked prosper. The Odyssey in its earliest form. Wrestling with the problem of divine justice millennia before Job, I think about the continuity of human concerns, how the scribes of Mesopotamia worried about education, about children who would rather play than study. We have their school texts, the dialogue between teacher and student, the father scolding his son for laziness, the complaints about how hard the curriculum is, how strict the masters are, and across 4,000 years, the essential experience is unchanged, recognizable, almost funny in its familiarity, or the love poetry. The sacred marriage texts between Inanna and Dumuzi, erotic and tender, celebrating physical desire, the goddess praising her lover's beauty, his strength, their union ensuring fertility for the land, the crops, the herds, and alongside the sacred texts, profane ones, tavern songs, body humor, evidence of a full emotional and sensual life, not just the monumental cue and the official, but the intimate, the playful, the human. The mathematical achievements deserve pause. The Mesopotamians understood the Pythagorean theorem more than 1,000 years before Pythagoras. They could solve quadratic equations, calculate compound interest, determine the volume of irregular shapes, and they did this with a number system that used position notation, understanding that the same symbol could represent different values depending on where it appeared, a conceptual leap that made complex calculation possible. And their mathematical tables, their problem sets for students, show a pedagogical tradition, knowledge systematically transmitted, refined, expanded across generations, the astronomical observations accumulated over centuries, revealing patterns invisible to a single lifetime of watching. The Venus tablets of Ammisaduqa, recording the planet's appearances and disappearances over 21 years, recognizing the cycle, using it to predict, and this patient observation, this commitment to record keeping, to building knowledge incrementally, represents a profound faith in the future, in the value of knowing, even when the knowledge has no immediate practical application. And the art, the standard of Ur with its panels showing war and peace, banquet and battle, the delicate shell and lapis inlay, showing such attention to detail, such skill, or the golden bull's head from the great lyre, fierce and beautiful, decorated with scenes of animals acting as humans, a lion carrying food, a donkey playing a harp, humor and craft combined, or the portrait heads, the gypsum eyes inlaid with shell and lapis, staring across millennia with an intensity that feels almost alive, almost aware. These weren't primitive people stumbling towards civilization. They were fully human, fully conscious, as intelligent as we are, working with the materials and knowledge available to them, solving problems, creating beauty, asking questions that had no easy answers, and succeeding, creating a culture rich enough, complex enough to sustain itself for 3,000 years. 3,000 years, let that settle. The span from the first Sumerian cities to the last cuneiform tablet is longer than from the fall of Rome to now, longer than the history of any modern nation. And during that immense stretch, empires rose and fell, languages changed, populations mixed. But the fundamental patterns persisted. The ziggurat at the city center, the scribal schools preserving knowledge, the legal codes regulating behavior, the astronomical observations tracking celestial time, until it ended, not in catastrophe exactly, but in slow dissolution, the center of gravity shifting west to the Mediterranean, to Greece and Rome, and the accumulated wisdom of Mesopotamia, its libraries and archives, became inaccessible, waiting in buried cities, in collapsed archives, for the archaeologists who would begin excavating in the 19th century, who would slowly, painstakingly learn to read cuneiform again, to piece together the shattered tablets, to reconstruct the voices of the dead, and now those voices speak again in museums and libraries, in scholarly editions and translations, the oldest literature, the oldest laws, the oldest cities, all emerging from the earth between two rivers, from the land that is now Iraq, still troubled, still marked by conflict, but holding in its soil the evidence of humanity's first great civilizations, the foundation upon which so much was built. I stand again at the edge of the idea, but now it has dimension, depth, faces and voices, not just abstractions, but individual scribes signing their names to tablets, kings boasting of conquests, lovers exchanging glances in poems, teachers scolding students, astronomers tracking Venus, mathematicians solving equations, all of them dead so long their bones are dust. But their words remain, pressed into clay, waiting to be read, to connect us to them, to remind us that we are part of something larger, older than we usually remember. The rivers still flow, the Tigris and Euphrates, though dams have changed their course. Pollution has dimmed their waters, but they flow, and the land between them still holds secrets, tells that have not been excavated, tablets that have not been read, whole cities perhaps still buried, waiting, and the influence ripples outward, invisible but real, in every city we build, every law we write, every story we tell, every calculation we make, every star we name. We are the inheritors of Mesopotamia, whether we know it or not, carrying forward patterns first established when the world was young, when writing was new, when the very idea of civilization was still being invented, still being tested, still being passed from one generation to the next, like a flame in darkness, fragile but enduring, bright enough to read by, warm enough to gather around, essential to everything that came after. The night deepens and the stars turn overhead, the same stars the Babylonian astronomers watched, the same patterns, eternal and indifferent, and beneath them the earth holds its memories, silent, patient, waiting for anyone curious enough to dig, to listen, to hear what the ancient voices have to say about being human, about building, about trying to make something permanent in a world of flood and drought, of conquest and collapse, of death that comes for everyone, king and scribe and slave alike, but also about the things that survive. The words pressed into clay, the ideas passed from mind to mind, The long conversation across time, which continues, which includes us now, as we too speak into the future, hoping someone will listen, will remember, will carry forward what we learned, what we built, what we dreamed in our brief time between the rivers of birth and death.